Oh, right. This is after the class. I've never done a review here where it's after the class. That's good.
I got to like page.
And we're live.
Page 3.
All right. Do you feel good about the first 3 pages then?
Kind of.
Good.
I have another paper.
Oh no. Oh no.
Parker's a beast.
Parker.
You can have it. I'm not going to use it right now. Actually, now that I think about it.
I will print one right now, and they'll be ready for Parker when he's ready. So let me do that, and then we'll go. Most exciting live stream ever.
Next.
Yeah, what's up?
Here. No, just right there.
Feeling good?
Yeah.
Yeah.
Feeling alright.
Oh, okay.
Keep in mind.
How do I make this work? Like log it into the wall.
Push the button because it turns on the outlet. Are you talking about the power strip thing?
It's on.
The tower? Yeah.
There's a button. There's a green line, so it's on.
Okay. So, we all collect.
I already did 16.
Which
I need help on 17.
Which, if you have
I need help
40,
on 16.
what that does is it everything in the chunk costs is 1 less.
Jordan, I'm sorry, I'm stupid.
Or
I'm
you
eating
get
my
more
crackers.
seeds.
I'm sorry. It's just really, really easy.
Sorry, I'm
You want a 40?
not
I don't
nice.
even know. I'm sorry, I'm stupid.
Put it on your lamp.
Okay, so here's how we're gonna do this. If you want to see a problem, you're gonna tell me to do that problem. You do not worry about what other people think. You just tell me what you need. We have plenty of time. Let's take our time. Especially since the beginning stuff really sets you up for success later. So let's make sure the beginning is really good.
I actually learned this stuff like in class. I did not learn it.
Right, but you did the other day when we reviewed it? Yep, I know. Same thing every year. Like, you guys are all individuals and you're all special and I love you all, like, individually. But, like, in general, high schoolers are very similar. All right, it's Algebra Final Review time. This is session number 2 for those that couldn't make it on Saturday because they had lives or something. All right, so let's get this fixed so it looks good.
Family Christmas.
Family Christmas. That sounds like Father Christmas, but like all of them at once. The entire Christmas family. Nothing wrong with that. As long as they're Visa gift cards. Those are the best. Good idea. Red Lobster, I thought growing up was like the ritziest place you could go to. Like Red Lobster was like rich people only. But you guys probably feel that because like you're from the sticks like I am. And then I moved to the big city and everyone's like, Red Lobster? No one goes there. You want real seafood, you go to like these fancy like non-chain restaurants. I'm like, what's a non-chain restaurant? Hi. Jenna, do you feel better about that one? Okay, good. All right. Was that a yes?
Yes.
Okay.
So we're putting this away now. That's fine.
All right. So, page 1. You want to go over the sets of numbers, or do we feel good about that? Okay. How do we feel about exponents? Wonderful. Speak up, okay? How do we feel about 13, 14, 15? You want to see them? It's okay. That's fair. 13, 14, and 15? Okay. Let's do both for 14 and 15. Because why not, right? If you feel amazing after 14, then we won't do 15. But, yeah. So the idea is we want to break these things up into ideas or terms. Okay? I'm going to shut the door so it's not. Make sure they weren't coming in here. All right. So here's the deal. This is one idea because it's wrapped in parentheses. Yes, there's 2 terms there, right? But we're going to think of it as one idea. Then we have division sign, which always separates ideas. There's another idea, followed by another idea, followed by another idea that contains an idea within it, right? And this one I am going to highlight. Is everybody cool with that? What I'm doing here? If you had to highlight the ideas, would you have highlighted them the same way? Good. Okay. So we're going to break those down, and we're just going to focus on this. 5 plus 5 is 10, and then we negate it, right? Then we have a division bar. That's what we should turn it into. It makes problems much more clear. Then we have 5 times 2, which of course is 10. Then we have a minus sign, so that's separate from this. That minus doesn't go underneath there. If this was wrapped in parentheses, that would be all one idea and it would all go underneath, right? But because it's not, only the first idea goes underneath. We're dividing it just by that guy. After we do all this, we're going to subtract 1. But before we subtract 1, we're going to divide that 1 by something. We're going to divide it by all of this stuff. 2. All of that goes underneath because it's all in parentheses, right? Does that make sense? Whereas here, that was 2 separate things. Here is all going to go underneath. So we have 2 minus whatever 3 divided by 3 is. So that's an idea unto itself. Does that make sense? How I set that up? And from here, if I'd given you the problem just like that, I think it would be very clear what to do, right? So now I do negative 10 divided by 10 and get negative 1. I subtract 1 divided by whatever 2 minus 3 over 3 is. What's 3 over 3? Good. Better? All right, Brainerd, I'll see you later. Later. All right, so that's negative 2. How do you feel? Pretty good about that? Okay. Breaking up the ideas really helps. I can make you a crazy one if you want to try another one like that. Want me to? Okay, let's make up one. Try that. Oh no, sorry. Try that. Have I tested to see if this is a nice problem or not? No. You're probably going to have to get common denominators at some point, but you guys can handle this. This is a tough one. As hard as it could possibly be, okay? So if you can do this one, you're going to be great. If you can do half this one, you're probably still going to be great, okay? So I'll do it on my own over here. Yeah, these aren't very fun. Break it up into ideas. Terms, right? No.
I'm close. Right, that's harder to get to. I feel like
That's okay. I didn't test this problem. Maybe 7.5 is valid. He's back. Yeah, can't forget that. I'll show you what I did to start out. I rewrote the problem, and I highlighted different terms. So we have one idea here divided by another minus another. Individually, there's some ideas here, right? And when I simplified that, I wrote it like this. Did anybody make the mistake of throwing the 4 minus all this stuff underneath there instead of just the 4? Yeah. Only that goes with. New idea, so it's separate, okay? If it was wrapped in parentheses, it would all go underneath there, okay? Again, the point was not to get this right. The point was to find out what your common mistakes are and be able to look out for those, okay? Okay, calculation is something that happens, but don't be worried about that because it's going to happen, and you're going to be fine. When things go bad, raise your hand, okay? But if you didn't make a mistake in the setup, that's great. That's really what I'm looking for here, right? Do you know what order to do things in and how to make it work? Maybe you say 3 times 5 is 8. That's not what I care about. I wish you didn't say that, but like that's not what I'm looking for here, okay? Does this idea make sense? Parker, 1 second. How do we feel about that? From there to there. Did you make the mistake of throwing everything underneath? Okay, good. All right, so now I'm going to do the next bit. That's negative 3 plus 10, right? Or 3 plus 10 and then negated, so negative 13 over 4. Okay? Then we can distribute the 3, or we can just do the math in here first, right? 5 minus 6 plus 1. 5 minus 6 is negative 1, plus 1 is 0. 0 times 3 is 0.
I got 18.
Did you distribute?
Yeah.
Okay, so 15 minus 18 is negative 3, plus 3 is 0. 15, negative 18, positive 3. 15 minus 18 is negative 3, plus 3 is 0. It's still 0. Why'd you get the 18? I'll take a look at your work in a second.
Because I multiplied by 3 and then I negated it. Like I distributed 3 and then I negated it.
You distributed the negative 3? So you got negative 15?
Just 3.
Okay, so you got 15. Then you got negative 18, right?
You just did it for 3 times 15.
I'm stupid. I did 3 times 2 and didn't even do anything.
Okay, well, don't do that. So now we get negative 13 over 4, which is as simple as it gets. Oh no, sorry, I didn't write that where you can see it. Okay, again, don't be mad about what you did. Learn from what you did and feel good about it because you found this mistake before it happened on the final, right? That's good. And that's really good. Again, the key mistake is not to throw all of this under the division sign, right? Knowing that separate ideas stay separate. Better? Feeling okay? All right, good. Jordan? Okay. You want to look at 15 or no? No? Okay. 16 through 19, page 3. Solving for variables. What ones do you want to see? None? 17. Let's do it. All right, so 17. To get p on its own is super easy. We divide by 2. Now remember, x, y is already being divided by 9. So if it's already being divided by 9, and we're going to divide it by 2 next, what's it really being divided by? Good guess. 18, right? So this is a bad example because 9 is such a big number. But imagine I had something that was already divided by 2, right? If it's already being divided by 2, let's say it's x over 2, and I want to divide it further by 5. Well, if it's divided by 2, there's that. If it's divided by 5, now it's that. How many pieces did I divide it into? 10, right? So if I have something and it's already being divided by 9, and I want to divide it by 2, now it's divided by 18. Another way to think of that is you can write it like this. Dividing it by 2 is just putting it on the bottom. It's multiplication. Right?
I was gonna say, can't you multiply by 1/2 on both sides?
You could do that as well, right? Which puts the 2 on the bottom, right? Multiplying by a half is always the same thing as dividing by 2. Clever. I like that. Next, to get x and y on its own, multiply by 9, right? So we have xy equals 18p, which means x equals 18p over y, and y equals 18p over x, right?
That's what confused me. Yeah, that's.
Just like a regular number, right? It's okay.
How'd you get x and y by itself?
Divide by y to both sides. Divide by x to both sides. Does that make sense?
Yeah.
What's going on there, right? If that was 2y, you divide by 2, right?
I was only confused on dividing by y.
Okay. Just because it looked weird, right? Yeah, but it's just like anything else. Trust your instinct. Your instinct is good. So now you know that your instinct there is good, even though it looks weird. It's good. You want to see 18 or 19? Okay, both? Okay. 18's not too bad. To get p on its own, I'm just going to add x and y to this side. So 4/9 is already there, and I'm adding an x and adding a y. Done. To get y on its own, I have negative y equals 4/9 plus x minus p. Do you see how I got to there? Move that by subtraction, move that by addition. And now to get rid of the negative, I'm going to divide by -1, which really just negates everything, right? And if it negates it, it means change the sign. So now we're here. Okay? To get x on its own, I'm going to move over the p by subtraction and add the y. And then I'm going to negate everything just like I did earlier, right? Is that visible to you? No, it's not. How do you feel about that one? Pretty good? It's a good 19.
Oh my god.
Doing good?
I did that all by myself.
Good.
Wait, you should go do number 16.
16? I'll do it when after I do 19, okay? 19, how do we feel about this one? This one's tricky, but I think we've done it enough where you might be familiar with it. But if not, I can do it again. You want to see it? Yeah, the quantity of it, right, in parentheses. Because it's 2 terms, if we want to move them both, we have to wrap it in parentheses first. Okay? So we're going to have 5 times the quantity of x minus y equals p. P's done. Now from there, we can figure out what x and y are, right? So I would divide by 5, and I get x minus y equals p over 5. And then I think it's easy to see what x would be next, right? X equals p over 5. Now the key is, when you add y, don't throw it randomly underneath here or on top. Okay? A lot of kids do that. I'm not sure why. Right, we have a fraction. We're adding a number to it. If you had a third and I wanted you to add 1, you wouldn't put the 1 underneath or something, right? You just do a third plus 1. So it's p over 5 plus y. For y, it's the same idea, except we're going to subtract x. And then we have to negate everything, right, to get rid of that negative. When we do that, we're dividing by a negative. So we get this. Ta-da! You can put the negative up top, on the side, or down below. It doesn't matter to me. Down below looks kind of weird, though. Yeah, that's what I do. If I'm writing an expression out, and I'm like, I have a 2 before it, I'll do 2 minus p over 5, right? Because that's easier than writing 2 plus a negative p over 5. How do you feel about that? Pretty good. Again, the key is that you have to wrap that in parentheses in order to move it. And if you don't, then you're going to be screwed up, right? Because then it's going to be 5x, and that'll get gross. 16. So we have to get x and y on their own. So I'm going to get x on its own first. The first thing I'm going to do is I'm going to move over that 1. So I have 3y minus 6 now. And now I'm going to divide by 2 and get x equals 3 halves y minus 3. Could you put it all over 2? Sure, but I think this is better, because that's like a slope-intercept form almost, right? But you could put it all over 2. That's fair. You could also take this and find y. So I'm going to write out the problem over here so we can see it. So finding y, I'm going to add the 5 over and get 2x plus 6 equals 3y. And then divide everything by 3. Again, you could have also done that one as this, all over 3, right? They mean the same thing. This is just saying I divided the 2 and got 2/3. I divided the 6 and got 2, right? Divide everything by 3. This one, we could have written it as, right? I like dividing everything up, even if it comes out to be a fraction. I don't know. It's just me. I think you guys preferred doing it over a giant division bar early on, but it usually causes more problems than it helps. We want to see 20, 21, or 22?
20.
Feeling like all of them? Let's just do all of them. Okay, that's fair. Well, to get P on its own, what would we do?
Multiply 2 on the bottom.
Yeah, multiply by a half, right?
Yeah.
So divide by 2, multiply by a half, same thing. So P on its own is going to look like this. We cool with that? It's already being divided by 5. When we divide it by 2, it's now divided by 10. Better? Okay. That's the thing that's weird for you guys. The sooner you get used to that, the sooner everything will start making sense with everything, right? It's really not that scary, right? You just got to know what you're doing.
I was confused because I did like 3 times x plus y equals.
So you just moved over to the 5?
I don't know.
I don't know what you did here. So remember, we've got options here of which one we go after first. Find the easiest one, which is P, right? And then think about what do I have to get rid of? The 2. I divide to get rid of that, right? Think about your game plan. Now, to get x and y on its own, first thing I need to do is get rid of that division. So I'm just going to go 3x plus y equals 10p, right? And then if I want to get y on its own, which looks the easiest, so I'll do that now, I'm going to subtract the 3x, right? Move that entire term over. One thing I'm really proud about this algebra class, I don't know if that sentence made sense. One thing I'm very proud of you guys about is that in this class, a lot of you guys see that we have to subtract the 3x to move it over, and you're not trying to divide, right? We want to move the 3 and the x, so we just move the whole term. Remember, when we move terms, we add or subtract, right? When we separation, it's division. Very proud of you guys. That's a very common mistake, and none of you guys seem to make it anymore. Next thing, to find x on its own. Well, I'm going to move over the y first, right? So I get 3x equals 10p minus y, and then I'm going to divide it by 3, which is going to get us this, because there's a 1 in front of the y. Or you could have written it like this. Either way works, right? I don't know what you prefer. Yeah, okay, if you want to do it all over 3, that's fine. The only reason I caution you with that is sometimes when you have to do work later with this, right, we're done, right? We're fine, right? So circling that and being done is fine. But if you have to do work later, sometimes that is easier to work with, right? So just know you have both, yeah.
Can I put, like, for the first one, the x equals 10/3 p? No, over there. Stop.
Yep, x equals 10/3 p.
And then can I put minus y over 3?
Yeah, you could also do that. So divide the 10. Whoops, that's a p.
Yes.
And then minus y over 3.
Yeah.
That works. Yeah. I bet if we were dividing it by if it was a 2 in front of the y originally, you'd probably put negative 2/3 y, right? You wouldn't put negative 2y over 3. But it's okay, personal choice, right? Again, some are easier to work with than others, but as long as you know it's all the same thing, that's what I really want to know, right? Looking at 21, p looks like it's the easiest to get on its own again, so I'm just going to get it on its own to start out. I'm going to add 4 and get 6 here. And then I divide everything by 6. So could you throw it all over 6? Yes. But I'd rather not because I already have a fraction here. So again, I'm going to show you what you could do, and I think you're going to agree that it looks kind of gross. Right? You could do that. But we have a fraction over a fraction, which is not ideal. Again, could you do it? Sure, right? You're circling it, you're done. But it's probably easier to work with if you write it like this. Divide everything by 6. 6 becomes 1, right? 3 is already being divided by 4, so now it's divided by 24, right? Now you might notice that that simplifies.
Did you just do 4 times 6?
Yeah, because I divide it by 6, so I multiply by on the bottom, right? That's all it is. It's already being divided by 4. When I divide it by 6 afterwards, it divides it into 24 pieces, right? Does that make sense? Oh, sorry, Parker. I'll get to you right after this. Yep, that simplifies, right? 3 to the top and bottom. That's what you're going to say?
Do we have to simplify it?
I'm not going to be picky on these ones.
I said, well, honestly,
But you should notice, like, just for fun, if I'm dividing 3/4 by 6, isn't 3 divided by 6 a half? So I'm really dividing 1/4 by a half, which is 1/8. I don't know. Another way to think of it. That might not have helped. I'll be back in just a second. Parker. Okay, so you did a good job there. Is this the test? And I didn't mark the ones that I didn't need to, right? Good, okay, good.
Alright, Mr. Mac, I'm out.
Alright, later.
Mr. Mac, I'll be back.
Okay. Okay, so the easiest way to graph it is put those two in and draw a line, right? So you did that. And now you're distributing to find slope-intercept things. And you got something awful, and the issue is that it doesn't look like it should be that. Okay. Plus 2 1/3. 1, 2 1/3. Yeah, it doesn't look like it should be that. So let's see what that is. Right? Because that doesn't look like the right y-intercept, right?
For this one, I don't know why.
Hold on. 9 halves or 11 halves is not 9 1/3.
So, this is what I did.
Okay.
I realized that this was the line.
Oh.
Wrong.
Got it, okay. Gotcha, so this is what we want, right? Okay, cool. So we distribute here, we get that, that's great. Now we're gonna subtract 7, so we need common denominators to do so. When we do that, how many thirds are in the number 7? How many thirds? Sorry. 21 thirds. So when we subtract 32 thirds minus 21 thirds, how much is left over?
Okay, that's what.
What?
You already did it, you just wrote halves. 11 thirds, 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 11 thirds. Right? So why does this? Oh, okay, I see what you're saying. You plugged in -8 and you plugged in 7. You have negative 4/3 of your slope, which is what we said it would be. Why is it off? Okay, well, let's make sure you graph your points right. 1, 2, 3, 4, 5, down 3, and then 8, 6, 7, 8, down 7, 1, 2, 3, 4, 5, 6, 7. Did you draw with a straight edge? Maybe your line isn't straight. Maybe it's supposed to lean a little bit lower.
Okay, what kind of, what did you do?
Yes.
What kind of?
Let me just see if this is right. If we take this and multiply by 3, we get 3y equals -4x plus 11. Weird x and y-intercept is what you have here. The y-intercept is going to be for x is 0, so it's going to be 11 thirds. Oh, God. 3, 6, 9, and 11 thirds. You're right. You're fine. You should have let half go there. So the problem was there was a 2 there instead of 3. So you're fine. Thought I was going crazy. Counting's hard. All right. Want to see the rest of 21?
Yes.
All right, so next thing that I'm going to do is I'm going to get x and y on its own. So the first thing is I'm going to move over that 2 and get 3/4 xy equals 6p minus 6. Then I'm going to get y on its own, but first I'm going to get rid of that 3/4 in front of there. And the way I'm going to do that is I'm going to multiply everything by 4, because that gets rid of the divides by 4. Would you rather multiply by the reciprocal? Is that what you guys did? Okay, then we'll do that. So xy equals, I'm just going to write this out to show my work. All that's the quantity and multiply by 4/3, right? Because you have to multiply both of them by that. Yes? Okay, so xy is going to equal 6 divided by 3, 2 times 4, 8. 6 divided by 3, 2 times 4, 8. or you could do individually over it, okay? That works too. It's gross looking, but it works, okay? Either of these work. Other thing you could have done is the same thing, but it's going to be with y on the bottom, right? How do you feel about that? Okay.
I'm confused on how you get the 4/3 like times the 6p minus 6.
Multiplying by the reciprocal?
Yeah.
So I multiply by 4/3 to both sides, right?
Yeah.
Cancels this. 4/3 times 6. 4/3 times -6, right? It's got to go to all the terms. Remember, we multiply or divide, it goes to everything. So 4/3 times 6. I wrote it like this because I know I will distribute, right? Are you confused about how I wrote it here?
No, I'm just
Okay.
like, I don't know.
What's 6 divided by 3? Times 4?
Oh.
Yep, okay, good. I just wanted to make sure the other things weren't tripping you up, so I could eliminate those and realize, oh yeah, it's just that. I wanted to ask about the difficult stuff first before we got to the obvious answer. Okay, 22. Let's get p on its own. Super easy, right? 2x squared plus 5/3 y can stay, and we're just going to subtract 2. Subtract 2, and that equals -p. How do we get rid of the negative? Negate everything, right? That's dividing by a negative or multiplying by a negative, however you want to think about it. And so it negates everything, and we get this. And p's done. Did I have to mess with the square? No, because it wasn't bothering the p, right? Now let's mess with y, because I'm afraid to touch that square. We'll save x for last, okay? So I'm going to move over the 2x squared, and I'm going to do that by subtraction. Right, I'm moving the whole thing over. So still don't need to touch the square, right? Just move the whole thing over. Was that what was tripping you up to find y? No? Okay, good. Okay. So now I'm going to multiply by 3/5. So I'm going to write that out so I don't screw that math up. Right? Does that make sense, how I wrote that with distribution? I'm just doing that so I don't mess up my math, okay? Because you could do it in your head right off the bat. That's going to be 2 times 3/5, which is 6/5, and -6/5 x squared. Okay, I'll take it. I'll hang on to it. Thank you. Bye, Haley. I hope you feel better. Yeah. There you go. Thanks. Do you see how I did that? 2 times 3/5, 6/5, right? Twice as many fifths. Is that okay? I am really proud of this algebra class. This type of stuff confuses people for years, even into calculus, and you guys really know your crap. You're not really afraid of fractions as much as you were, right? Hey, Jenna. Okay. That's y. Now let's go get x. So way over here, 2x squared stays. 5/3 y moves over to here by subtraction. Okay? Making sense? Now I'm going to divide by 2. That's -1/2 p, or -p over 2. You might have done it that way, Nevaeh, right? -p over 2. 2 divided by 2 is 1. 5/3 divided by 2? 6/3. Still negative. With me? Right, 5 is divided by 3. If we take something and divide it by 3 and then divide it by 2, it's dividing it by 6. Feeling better about that? Rad. That's awesome. Now we're going to root it. Everything under the root. Just write it all underneath there. That's all you do. If you try to get rid of the root first, you're going to have a whole mess. Okay? So just save that for last. And then root it when you're done. How do you feel? This is literally the hardest it could be. That problem right there is as hard of a problem I could throw at you.
Once we got to the part where you would divide by 2 and got x squared on its own, I remember.
Rad. How you feel? Good? I think if I really wanted to throw you a curveball, which I won't on the final, the only thing I can think of that would make it harder would be to put this all over 2, and you'd have to do that first, which wouldn't be hard, right? Just times by 2. Exactly. It's just weird looking, right? But yeah, that's not hard. Or you could think of it as divide by 2, and that's a 6 now. See what I'm saying? And the fact that you get that means you really know your crap. You should feel great about yourselves. Like, I'm imagining, like, regular math classes doing stuff like that, and they'd just be completely lost. I remember me in high school, and I was not very good at math, so I'm a bad example, but even then, like, I would have no idea what to do with this stuff. I would goof it up so badly. And you guys, like, might make small mistakes with arithmetic, like saying 3 times 2 is 5, right? But you know what to do, right? Again, calculation, hard, but you guys actually are really good at algebra. Okay, want to see 23 or no? Kind of? Okay.
Okay, so that's 14. Nice. I have 3 of these. Hang on. 1, 2, 3, 4, 5, 6, 7.
That's how I did it. It could all be over 3. Notice that all these have 3's in the bottom, so it could all be over 3, right? Mm-hmm. And then to get y on its own. And then I divide everything by -4. So it's -3/4 x, positive 11/4 equals y. Again, they're all over 4, which means I could just do a giant bar with a 4 underneath it, right? That's the other option. Three divided by -4 is -3/4.
Can you do it
Negative and negative is positive.
by 4 first and then, so it'd be like a negative y and then do that? Will that not work?
Yeah, so you could have done an intermediate step and did this. Right?
Yeah.
And then it would negate everything, right?
Yeah.
Yeah, rad. You guys are actually really good at algebra. And I like that you think of things differently and are like, yeah, that would be the same, wouldn't it? Right? Not like the way you did it wasn't like, oh my god, I did it wrong. You're like, wait, that's probably the same, isn't it? That was brilliant.
7th grade math, I almost failed the class, and then 8th grade math, when we started doing like more algebra stuff, I really improved, and I got like the math award last year because I improved so much.
Rad, rad. No, you guys are actually really good at algebra. You've come a long way since the beginning of the year, too. You really have. Calculation, not the best, but we're getting better at that, too. A lot of you guys are doing math in your head that you never did before, right? Exactly, right? Yeah, and if you break it up differently, it becomes a lot easier, right? It's how you think about it, right? Again, who cares about the answer? It's how you come up with it that's way more interesting. In some ways, they're better than others, right? More efficient.
Yeah, I'm glad I did Euler science that time.
How about we get rid of the division first and then divide? Or you can just divide 13 both. Let's make 13 divided by 13. 13 divided by, negative 13 divided by 13. There. We doing 24? Can I not get p on its own just to save time? Add 1 divided by 4, right? It's going to be divided by 12 underneath here. Rad. Love it. All right. We cool with that? Distributing that 3, right? Hits everything. Did you miss the distribution?
Where does that 1 go?
Becomes a 3.
Yeah, but like when we find p on our
Oh, okay. I'll find p. So to find p, I'll do that over here. It's okay. I'm just writing it over here. Okay. I'm gonna add 1 first. It's here, right? If we had a third plus 1, you wouldn't put the 1 underneath or anything, right? It's just a fraction plus 1. And then we divide by 4, we get this. A quarter. Fun fact, you can get common denominators and put that all together. You see that?
Yeah.
God, that's rad. You see that? Well done. Well done. Guys. You're freshmen in algebra, so sophomore geometry. Okay, so you're just going to miss calculus unless you double up. You should totally double up. The hardest part about calculus is knowing how to deal with this crap. because a lot of that just pops up naturally, just is a mess in sorting through the weeds. I always say calculus easy, algebra hard. You guys are really good at algebra. You would destroy calculus. All right. So getting x and y on its own.
She's not answering you? No. I want tacos at this moment. I'm freaking hungry. And I want cheese.
This one's weird.
Okay, I
You
multiplied.
want to write the lines for both of these, or just like?
Oh, you got y equals, you got a slope-intercept form. If you want to graph them, which I do want you to do. Yeah. Oh God, you're solving by graphing. Why are you doing all this work?
So it's not solved like that.
Exactly. So you want to graph them and figure out where they intersect. What I would do is I'd move that over and get it into standard form. Way easier to graph and slope it. To graph there, right?
Isn't that what I did? I like moved that over.
That's not standard. That's slope-intercept because it's the one with the slope and the intercept. This is hard to graph, but it'll be easy to graph if you do standard form and find your intercepts. Do you know how to find your intercepts?
Yeah.
Yeah? For real?
So-
Do that. That'll be way easier.
So this would just be the point where they intersect.
Yes, probably. Yeah, probably. Yeah.
So then just draw the line.
Mm-hmm. Yeah, you caused way harder work for you. Be nice.
Heard from her mother. Birth giver. Mother Goose. Madre. Why am I listening to words?
I don't know. So, Taylor, does this make sense? I did call you Taylor. I'm sorry. It's because of the glasses. Jordan, does this make sense?
I got x equals 12 sevenths minus 8 sevenths over y.
Say it again.
X equals 12 sevenths pb minus 8 sevenths over y.
All over y. That works. It's gross, but it works. Here's what I would do to make this seem less weird, because it is kind of weird, right? Divide by 7x at the same time. Put everything over 7x and look what we get. That makes sense, right? I did it by 7 first, and then I put the x underneath, which is kind of weird, but it works. Y would be the same thing, just x and y would be switched, right?
When was the last time you talked to her?
Alright. So like these are just simplified versions of these. So I just use that to like graph a line that it should go through the point.
Oh, sure, you can do that. Yeah, yep. I thought you had a weird y-intercept. You don't. You're good. Okay. I mean, in theory, they're the same, right? Yeah. 25. Only thing funnier than 24. We doing them all?
She will not answer me, and I texted her at like 3-4.
I'm going to get y on its own first.
Okay, well, I don't know. Yeah, I'll just sit here and text. Yeah, she just texted me. Bye. Is that Julia? Yes. Do you want to go with me? Sure. Is she here right now? She's almost here. I get tacos. Tacos. Oh my god, you freaking tacos. But I'm sorry, I am in love with beef tacos. Freaking OT beef tacos. No, I would rather marry that person. That person. I'm just copying this down and then gonna figure out how to do it in a second.
Why do that? Why copy it down? It's right there. I'm not going to move the page. I'll leave it right there. I did 4/9 divided by 2, and I made 2/9. You could have done 4 over 18 and not simplified. Right? Mm-hmm. Mm-hmm. I just saw that I could divide the 4 by 2, right? If I have 4/9 I cut in half, now I have 2/9, right?
Yeah.
When I can divide the numerator, I do. Red. Make sure to say thank you. She's really nice. Yeah, I think you guys are going to crush this tomorrow.
The only stuff that I don't really get is the stuff we just learned.
Okay. Well, we're going to get to that. Okay. And I think you get it. It's just you don't have the confidence yet. That test took out a lot of confidence from people. And I think it was everyone was really stressed about finals and all the stuff, right? And it caused you to lose your goddamn minds, right? So we're gonna undo that mental damage and scarring. And you'll be okay. Parker. Yeah, get X or Y and then plug it in, right? Substitute means switch out. Switching out Y or X for what it is. You're gonna be okay. You really will.
Is it positive divided by a negative and negative?
When you multiply or divide by a negative, it just means change the sign. Does that make sense?
Yeah.
So a negative divided by a negative means change the sign. It was originally negative, so now it's positive, right?
Yeah.
A positive divided by a negative says change the sign. It was positive, so now I'm making it a negative. Instead of telling you guys that dumb rule, negative times a negative is positive, right? 2 negatives make a positive. Explaining why makes sense. I like how you reason through things, Parker.
Wait, hang on. Wait, no.
Can you see if I did this right?
He wins.
No.
It's compare higher farms. How did you win? Andrew wins.
Interesting way of getting DNF. Why didn't you do this?
Okay.
Done.
I have one racing strap.
Or divide by -3. When you do that, you take it. 3 times a negative, you have to put a negative there too.
You are so cute. Here's your Mac, I'm leaving.
No! Okay, bye.
Bye, thank you.
Of course. Were you waiting around for me, Jenna? You weren't?
I was
Okay.
just watching the video.
Okay, cool. Rad. Alright, later. I want to make sure I wasn't ignoring her.
If you want any cheese sticks,
I appreciate the offer. Thank you.
Have one?
No.
I would literally pay for it.
We're not doing that. Nope, 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 nope.
go for options. Try not
Sorry. Her mom bought it. We're not sharing it with Game Club.
Oh, yeah.
I'm not supposed to have not in good
Do not solicit her for cheese sticks.
Okay, don't make Andrew yell at me.
All right, kiddos. How do we feel about these? Jordan,
Yeah.
how do you feel about these?
Good.
For real?
Yeah.
You looked at them?
Yeah.
Glorious. Olivia, feeling good? Or not sure yet, because still got to do the work. Okay. I'm going to use this time to go get a soda.
Oh my god, this is glorious.
The last one. Who? Who's Grant? Oh, Grant. No way. Grant's rad. He has great musical taste. He's a super nice dude. Right?
It's actually my mom's
Gotcha. He's awesome.
I have one racing strap on it. It's so awkward. I was running through the freaking hallway and I had one racing strap on it. It was so weird. Wait, the straps on your tops, they're called racing straps.
Really?
Yeah.
Racing straps. Wow.
Sports mode, not racing straps.
Sports mode.
Racing.
That's amazing.
Okay, let's see if I can use this one. This one is a lot.
I'm snatching that
And
one.
she's saying, I am. She's, I'm 3 beef tacos with lettuce, tomato, and cheese.
You guys ordered it here?
No, my mom did. I know what I want when I want.
Shout out to Olivia's mom.
Yeah.
What a G.
I have to be.
Okay.
I have to be. Penny Grace.
Who are you talking to?
Jordan. No, I said I have to eat.
Oh.
Guys, Nevaeh's so dumb. Oh my god.
Why are you laughing at me? I'm hungry for you.
Yeah, you are. The only thing keeping her from taking a bigger bite is her brace rubber bands.
I never do bands. No, they're on your pencil.
Oh, took them off so she can take big bites. That's right. It's getting serious. It's taco time.
No, you gotta say I'm
I never eat, okay, Olivia? I'm eating hands. This is why I'm skinny.
Jordan's going to Taco Town.
Whatever you like tacos.
Wow.
No, wait, who are you
Now I'm
making this
freaking
for?
in love.
I'm gonna check out the pentagram over on my wall and make sure it's not too satanic. You don't want to summon a demon on accident.
She's out.
Oh, wrong.
No, she's out. It's down with Grace and Andrew now. That's what happens in 6th hour.
Yeah. Oh, that was
Jordan, you were too much. You were getting
really hoping that's like a double.
my goddamn hair back.
What?
leave it, Andrew. Andrew. And seeing you. Re-seeing you.
She's
Re-seeing you.
I am putting my hair back.
Wow.
Please chill. Please chill. I never use this sometimes.
Wait, where'd your ex go?
My cheese is melted.
Wait, you can't play that with only 2 people. Because then I can't do shit.
She can play the hammock. He can play the hammock.
Then what do I do?
Yeah,
You
right.
just do
Anything
action
that
and you
is
discard it.
zero, so that must be 0, so x is 0. That's exciting. Hopefully that's right.
The thing that you wanted to do cancel.
She got napkins because this isn't good. I do not use napkins. I'm sorry. Jordan, you need to use napkins. No.
Yeah, but not
I caught it when it was.
Oh, okay. Here's my first of all.
Okay, like.
Yeah, you haven't said it. We just run and give sweet princess and all that. I had to this whole game.
You really messed up that bad where you had him who didn't even act.
No, my mom's great.
Jordan was going to Taco Town, express ticket. She took off her rubber band so she could take bigger bites.
We're not supposed to eat.
The count is actually like.
We're not supposed to get back.
That's right. She's like, it's time.
She puts her hair back.
Okay. Andrew, you get another card. Yes.
Sorry.
Just another day in the life.
Oh, warm tomatoes. But I literally.
I don't have money anymore.
Are we good on 25, Olivia? Yep, for real? Okay, awesome.
I ate tomatoes this
26, need to see it? Let's do it. I'll write it out really quickly. I'm gonna get P on its own.
It's your turn to start again.
That was a weak
Oh,
one.
were you guys taking this early?
What the heck?
Okay. I saw somebody take that and then
Yep, I got creative. Yeah, Nevaeh's not big into simplifying.
No.
Mm-mm. She's just like, write it down, who cares?
I'm just paying attention.
The problem is done, I do not care. But like later you're gonna have to do stuff like after you get that, and you're gonna be like, oh man, this is such a complicated problem. It's like, well, you could just reduce everything. 6 divided by 3 is 2.
Yeah, I know, but we're the 2. Wouldn't it be 2x minus 2y?
What are we looking at here? This one?
To get
Oh, you could distribute the 2 if you wanted. I just chose not to distribute it. I divided by 2. Right? So starting from here, I did this one. So I just divided everything by 2 times a half, right? Yeah, you guys are really good at this stuff. Very happy with all of you. Very happy with all of you. One of the nice things about algebra is pretty much everyone has to take my final, whereas in geometry there are a lot of juniors that don't have to, and usually those are the kids that are really good at it. So grading them is going to be miserable because I'm not going to have all those good ones to be like, yeah. But algebra, you guys are all taking it, which means I'm going to be like, yes, all the time. Because of your heart issues?
No.
Okay, I can't remember who has heart issues and who isn't.
That's me.
I'm party.
Okay, awesome, me too. Or at least I did.
Take medicine every day for the rest of my life.
That's right. What kind of medicine do you take? The Digoxin? Hopefully not that, right?
It's not. It's like.
And I have 5
I don't know. I have to get
Yikes.
something tested again because my dad has it.
Yeah.
And my grandpa, only 40% of my grandpa's heart works.
That sucks.
Yeah. So they think I might have a test.
That's awful.
Yeah.
Catch it early though, right? Yeah. I understand that life.
My mom was healthy as a horse, so.
Awesome.
I was in the hospital room because, like, when I broke my arm,
Yeah.
the doctor asked if I had
Oh, I know what I got.
and my mom was like, no, she's as healthy as a horse. And, like, Mom, sure.
My dad has something wrong with his cholesterol thingy, whatever that is. Gotta get tested.
Cholesterol.
Yeah, that. Gotta get tested for that. He has a lot of medicine he has to take every day.
Gotcha. Exciting. Who knows? Maybe and you have an arrhythmia, right?
No?
An arrhythmia, it beats too fast, or it beats irregularly.
Yeah. It beats fast and then it will slow down. Like, it'll be like 136 and it'll be like.
Do you know why it does that? Okay.
When I was in the hospital, my heart rate was like 135.
My sister's resting rate is 175. It will be her whole life. Yeah.
That's how mine is.
hmm
It would be really low or it would be really high.
Mine after surgery is like so low. Like when I was in the hospital post-surgery, I'd set off alarms all the time because they think I had died. Because my heart just beats like once every like second. Which is why when I go in for a checkup, which I never do because I can't afford it, but when I do, they're like, oh, you must be like a long-distance runner or like a cross-country swimmer type of deal. It's like, no. I treat my body like garbage. I just had heart surgery.
So since everything would just be divided by 1, it would be the same thing.
I thought when you said life support, I was originally thinking child support. That makes sense.
Everything divided by 1, what do you mean?
So like, isn't this the one where you substitute like that for 0 to
I might
get
have to
1?
get my other taco. I might get to eat your other taco.
This is where linear combination is when you line them up and then subtract to make them go away, right? Or add. What did you do here?
There was like something we did where like you would like.
Oh, finding the X and Y intercepts. That's what you forgot in the last time. That's not it. Okay.
Not that.
What you need to do is line up your X's and your Y's on one side, get them in standard form like this is, and then you're going to multiply by stuff to make them match, and then either subtract or add to make them go away. Do you remember that one? This is going to be weird. Think outside the box for what to multiply by. Don't be afraid of the fractions, okay? Remember, they're just division for lazy people. 27, 28, 29, yes or no?
No.
Oh, I'm so
Are we feeling confident? Okay. Let's move on. How do we feel about 33, 33? Solid? They're super easy if you know what to do, but honestly, I give this to people still, and they're just like, I have no idea how to do them, right? Yep, if you know what to do, it makes a lot of sense. Moving on to 38. Want to see it? It's easy if you know what to include, okay? So I'm going to do one of them, and then you're going to go, oh, no big deal. One thing we have to watch out for when doing inequalities is when we divide or multiply by a negative, what do we have to do? No one was listening. Exactly. So multiply or divide by a negative, change the sign. Guaranteed people will miss that tomorrow. Guaranteed. Don't do that. Don't forget to flip it. Nope. So that's going to be 20. Ugh.
Why not? I have to study, dude. I don't know any Spanish. I have my Spanish final tomorrow. I wrote that whole portfolio in one night. It took me 4 hours.
Yep.
Bad decision. Oh crap! I forgot about that.
Graphing it and writing set notation. Yep, that's why I decided to do it, even though no one wanted to see it. Oh, so close. Almost the bank shot.
Oh my god.
Wait, what did I not go over?
Markers.
Oh.
It's okay.
I was just hoping a little bit like, I was just hoping that
Yeah, I know.
So solution set, graphing. Yep. How do we feel about those? Feeling good?
You should do 39.
39?
That one looks like
39?
yeah.
39.
Yes.
We flip the sign because we're dividing by a negative.
What?
We flip the sign because we divided by a negative. Remember that thing I said, the one thing we have to remember is flip the sign when we divide or multiply by a negative number? Before I started any of this, I was like, what's
How'd you get X on its own?
divide by negative 3?
To both sides?
Nevaeh, I'm going to make up a problem that has nothing to do with this. Okay? And I want to ask you how you would solve it. How would you solve this problem? Has nothing to do with what we just looked at. How would you solve that?
The sides and Y. Wait.
Ones and equals, ones. It's the same idea, right?
But wouldn't it be negative?
When we divide by a negative, it becomes a negative. And then we change the sign, right? So set notation is all real numbers. Now pretend the problem was something like talking about people. Well, first of all, it would be negative, right? But like if it was talking about people, we'd write something like this. Integers only, right? Or we'd write like natural numbers only, right? If it was talking about people, right? It's not, so we just write this, all real numbers. Or you just write X. Like that. Right. But remember, there are other things like we could restrict it to natural numbers, whole numbers, etc. Right?
Okay, I'm fine with that.
Okay. I figured you guys would be. Again, open circle means it doesn't include it. Closed circle means it does.
Wait, that also means a line.
Mm-hmm. Right. Because it could be that, or it could be greater than, something like that. Right? Mm-hmm. 44. Same thing. It's just two of them at the same time. Okay? Feeling good?
I had to
Yeah.
untie my pants.
Oh my god. All right. It is Taco Tuesday here for algebra review.
I didn't expect them to be this tight.
All right, we ready to do 44?
Of course.
Same dumb crap,
Oh, that's easy.
right?
We restarted. Sorry, I have no idea. So am I, dude. I think I'm high on this or something.
That would be a little scary.
I did.
Other side.
Did I divide by a negative?
Probably 'cause I'm
Oh, wait, no.
drinking Mountain Dew.
So for this problem, x can be all real numbers because they didn't say it was like a word problem or anything. It just has to be greater than 6, or it has to be less than or equal to 2. When we go to graph that, it's going to look like this. 6 is bigger than 2, so I put it on the right. Open circle for 6, closed circle for 2. Less than or equal to is over here.
She's laughing at me. It's 'cause I'm drinking Mountain Dew. So what I get like.
She can't drink Mountain Dew.
I know.
Wait,
Who got you that?
Yeah, she put
she
it.
got it herself. I was gonna get us Pepsi. Get her Pepsi and Sprite. But she forgot. So we had to get something out of the thing over there, like the machine.
They're not supposed to have Mountain
Just give me
Dew.
Mountain Dew. This is why.
Give me it. Your dad literally does not let you have Mountain Dew.
I know.
Or your mom.
No,
So give me
my
it.
dad would. My mom doesn't.
No,
There's
your
so
mom
much
does,
sugar
or
in
your
it.
dad doesn't.
Huh?
Her dad doesn't let her have it.
My mom doesn't.
No, your dad doesn't. Remember when you were at DQ?
Oh, okay. Whatever.
Oh, yeah.
Wouldn't let her have Pepsi?
Exactly.
Okay, then yeah, definitely Mountain Dew probably wouldn't be a good idea. All right.
My mom's not my person. My dad lets me. I just tell my mom.
Okay. 45, or do you want to stop? That's it. You want to see 45 or no?
No.
One thing about 45 is that instead of writing and in between here, because it's an and one, you can kind of combine it. So when I say a number between 1 and 10, I would say something like this. This is not this problem, obviously. But between 1 and 10, here's 1, here's 10, here's the number it's between, right? If I want to include 1 and 10, I do that. So an and statement, you can write all in one thing. You don't have to, but it makes a lot more sense between 1 and 10, right? Feeling good?
The last 2 cheesesteaks. So sorry.
Do it. Don't be sorry. Never look back. You want to see 52 or 53?
What is it?
Yes? The membership cost is $200. So for a member, the member total cost is going to be $200 plus $6 every time he rents it out, right? So number of court rentals. And then we have non-members. And it says that that's going to be $15 every time, right? So the question is, when is this going to be cheaper than that, right? When is becoming a member actually a good deal? So we want to know when member cost is less than or equal to non-member cost. That's what the problem wants, right? So what is member cost? Well, it's $200 plus $6 every time they use the court. What is non-member cost? It's $15 every time they use the court, right? Making sense? Right? So now we just do math. We subtract 6, C, and get our C's together. And I divide by 9.
I'm extremely full. You ate 4.
And we divide dollars by dollars, it goes away, right? And we get court rentals. Anything greater than or equal to 200 divided by 9, which is approximately 20, right? Right? So that's the idea. Now we know court rentals can't be fractions, right? So what set of numbers does court rentals have to be in? What set of numbers?
209? No.
No. So we can't have a fraction of court rentals. You either rent it or you don't, right? So it can't be all real numbers because that would include fractions, right? So what set of numbers does C belong in then? We've got options: integers, rational, whole numbers, natural numbers. Rational? Rational includes fractions. Integers includes negatives. Can we rent the court negative times? Nope. Natural numbers. Could the court rentals be 0 though?
Yes.
Yep. So it's whole numbers because that includes 0. Court rentals can be 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So it's natural numbers. But C has to be greater than or equal to 209. 200 over 9. Anything greater than or equal to 200 over 9, but it has to be a whole number.
Okay, so now there's a.
Now we're here. So that's times by 2 and divided by 3. You don't have to divide by 2 and divide by 3. I'm going to divide by 3 first.
Bro, what else have you been?
53. Isaiah has $600 in the savings account at the beginning of the summer. He wants to have at least $250 by the end of the summer. So he's starting with $600, right? And he's withdrawing $35 per week.
He's not a puppy anymore. He's just really small.
And he wants to have it.
Exactly like we just have to take a review, put it on the desk.
And change the numbers, yes. And then cut some problems. A lot of problems.
Wait, are we allowed to listen to music during this or not? We can? Oh, this is just like the normal text.
Remember when we had the conversation earlier and I said you don't need to worry about this? Guess what?
I didn't think you could listen to music.
I worry about it.
I was right. We have to have at least 250 by the end. So after we do all this, this needs to be greater than or equal to 250. Right? Because what does this stand for? This is the amount left over, right?
Plastic.
Oh, God.
Paper. I'm chewing on it. And it's in my hair and on it.
Yeah, you know what I'm saying? Wait, is that a negative? Yeah, is there?
Both negative. Negative, right? Because we're subtracting. Negative, because when I subtract 600, I get negative.
But like, is there a sign for I'm sorry.
It's okay. Do we understand what's going on here?
Yes. It was good to tell. That's all we'll do, like art class.
Okay. So how do we write the set notation? Well, weeks can't just be anything. It has to exist in a certain set. Can weeks be a fraction? Nope. Can weeks be negative? Nope. Natural wouldn't include 0. Can weeks be 0?
Yes.
Whole numbers. Ugh. You don't know the sets of numbers?
What is that?
Shut up. Shut up. Shut up.
I love it.
You don't know what the sets of numbers are, okay?
Like I know the symbols for like the N and the 0. I don't know.
Well, they're on the front page in the chart, but no one ever looks at those. But here's what they are. Natural numbers are starting at 1. Whoops, sorry. Natural numbers are the numbers starting at 1, 1, 2, 3, 4, 5, 6, 7. So it's n sub 0. Sub meaning subscript, right? I'm sorry, n sub 1. N sub 0 is the natural number starting at 0, otherwise known as the whole numbers, right? Yep, I know. Long time ago I mentioned it, but no one actually paid attention because they thought there's no way we'll be quizzed on this because every other algebra class I teach you in the first week and it never comes up again. But I use it all the time. Why? Because real mathematicians do, and when you get to calculus, they should be using them. Usually they don't. Then we have the integers, which is z. So the way I think of integers being z is I think it's the natural numbers turned on its side. We have the positives and the negatives, right? That's the integers.
Can I go get gum from my locker?
Great idea.
What?
Yes.
What kind of gum do you want?
I don't know.
Set Q is the rational set.
Yeah.
Yep. And then we have the irrational set, which is P. And then, of course, we have real numbers, which is big R.
Andrew, is yours out? I'm protected.
I'm not going with them, but can I go to the bathroom?
Yes, go ahead. We are taking a break. We only have an hour left, by the way. Actually, we have more than an hour because Troy and
She received the princess recently.
Mitchell will be here.
Yeah. She didn't have the princess then. She drew the princess. Oh. Okay. I had a game. And everyone else played everything else. Yeah, you got the princess. Yes, because you won. No. You had the princess at the end of the game. Wow. No, I know. Well, you were wondering how I knew. Tell me how I knew. So we'll be waiting for Grace. Well, we could have anywhere from 1 to 2 games then. Most likely up that there will be, actually, there's an equal outcome where there will be 1 and 2 games. The chance of there being a third game, you have 1.5 and then 1.
You're finding out this test is really freaking hard. Yep. 24 over what? 24 over 9? So it's 24 9 divided by 2 is how many? Oh, you could even simplify that further if you wanted.
That's a little lewd. Andrew, you got the
My game club, all I hear is, that's a little lewd. We are gross and we're sophisticated. Lewd.
You need to speak up. I'm writing for the new John Mulaney special. Me too. You know what it is?
Wait.
No, John Mulaney and the sack lunch brunch.
Wait, say to make you so closely. You guys hold hands.
Okay, I know a man will use this.
Yo, what?
Yo.
It's not?
Yo. There's no left.
God.
Yes, I got sauce.
Okay,
That's taco sauce. Okay. Alright.
Hey.
Wait.
What? Where can you look at it? You can smell it.
Wait, no, that's your fault for leaving your car.
Okay.
Okay, so it's my turn. So I handmade myself this time. You know why? Shut up. You're not supposed to make comments outside of the game.
Bad news. How did I go?
No, no.
Whoa.
What?
Are we just writing? Did you look at it?
No, you have to discard it.
What are you doing?
Are you like starting?
Discard it.
Natural numbers, whole numbers, integers, rational numbers, irrational numbers.
Grass.
Oh yeah, and then real,
Have.
which is everything.
36. You really went out.
36.
Yeah, I did.
Wait.
No.
I don't have
actually giving us like.
Oh, just like,
I feel my stomach hurts.
it could be a lot.
I had 4 tacos, so it's just no reason.
Sets of numbers. You should probably know them. Are we good? 30, 54, want to see it or no?
Okay, no, that's too late, that's too late.
57.
Okay, so.
1/2 of a number.
Oh, is it?
Increased by 3.
No, you give me out.
Or all of that from before
Andrew.
is less than or equal to -3. That one's a very convoluted statement
Grace.
because it switches subjects. Oh, I mean, it has a clause and it's using the same subject, and the subject is this. English is weird.
Grace, congratulations.
How do you feel about that?
If I'm correct, you had a friend's name.
Nope.
I have a
But you could. I bet you could. How do we feel about that? Better? Okay. 58. 9 less than a number, I'm going to use n, is no more than 8 and is no less than 3. So what do we mean by is no more and is no less than? So over here, this thing is no more than 8. So which one's bigger, 8 or this? 8 is bigger, so it's going to point this way. No more, meaning that it could be equal to, but it can't be any more. If this is no less than 3, then which one's bigger?
N minus 9.
Yep. And it could be equal to 3, right? Well done. The sum of 4 times a number and 8. So 4 times a number and 8 being summed is between 0 and 12. So here's 0 on the left and 12 on the right. How do I write between?
When this 0 is greater, 12 is greater.
Less than and less than. Right? 0 is less than this, which is less than 12. It's in order of biggest to smallest, or smallest to biggest, right? It's between those two. The sum of 3 consecutive odd numbers is between 26 and 34. Well, it's between 26 and 34, right? So let's start with that. Right? Between 26 and 34. Sum of 3 consecutive odd numbers. N is the first number, and then what's the next odd number? Right? So think of an odd number like 3. If you add 1 to 3, you get 4, so that's not going to be enough. So we're going to have to add 2. 3, I was going to ask you a question, but you guys jumped to conclusions. You're like, oh, that makes sense. Okay, imagine an odd number, right? 3. Is 3 plus 2 the next odd number? Mm-hmm. And then is 3 plus 4 the next odd number? Right? Now, we have to make a restriction. N just can't be any number. N has to be what? What kind of a number? An odd number. So we're going to say exist in the odd. Okay? And it's between this. And if you want, you can wrap it in parentheses for organization. Mitchell said you guys did that last year. Yep. I like organizational parentheses. I don't know who your math teacher was last year, but I think I like them. You speak no evil. What is slope? Want to talk about it or no? We are going to do every single one of these problems, aren't we? If you know it, let's not do it. How about I just talk about them? Vertical distance, horizontal distance, right? Because subtraction is distance, right? And that's the explanation. 62, slope-intercept form. It's the one with the slope and the intercept in it. Y equals mx plus b. Yeah, it's the one with the slope and the intercept, right? Which intercept? The y-intercept. Point slope form, just so we're clear, is y minus k equals m times the quantity of x minus h, where h and k are your point. And of course, m is the slope. And remember, if h and k is your point, when you plug it in, it changes the signs, right? That's why there's minus signs there. Remember that? So if you want 2/3 to be on your line, then you plug in -2 and -3 over here, right? That's what the negatives mean. They mean change the sign, right? Calculating slope. Slope. I used to have a teacher. Did I tell you about this? I had a guy named Mr. Rhodes, as my 8th grade math teacher, and Mr. Rhodes would rap for us after class. Yep, he would. And he was teaching us about absolute value, and he's like, absolute value is like your washing machine. You put in your dirty laundry, you put in your clean laundry, you put in your soap, and you turn it on, it all comes out clean. Dirty laundry, clean laundry, all comes out clean. Anything you put into it comes out positive. And again, that soap thing was like a joke for years. Soap! Yep. Shout out to Mr. Rhodes. I have an award in his class that I got for something, I don't know, but it's hanging in his classroom. My sisters all saw it, and they're like, yeah, I don't know. Do you guys want to calculate slope? Do you want to calculate slope or no?
Yes.
Well, it's the change, the vertical change over the horizontal change, right? So here's our vertical number, and here's our other vertical number. I'm choosing to go in this direction to be consistent, to go from the left or the right coordinate to the left coordinate. So how much vertical change do we have here? We're going from -2 to -1. We went up 1, right? How much horizontal change do we have from 0 to negative? Down 2. So our slope is -0.5. That's it. Could you have plugged that into the slope formula, y2 minus y1 over x2 minus x1? Yeah, you could have. But that's way easier, and you're not going to make a mistake doing that, right? When you do the formula, you're probably going to miss a double negative. Here, this makes sense. So then it says, write point slope form of each line. Well, it's going to be y equals -1/2 x plus b. To figure out what b is, oh, that's slope-intercept. We could plug in one of our coordinates and find what b is. You want to do that? Let's do it. Let's plug in this coordinate. -2 for y and 0 for x. Turns out b is -2, which makes sense because 0, -2 would be a y-intercept, right? Whoops, -2. X -2. Right, and again, 0, -2, of course, is the y-intercept, right? Duh. We also need to do point slope form, so that's going to be y minus k plus equals m times the quantity of x minus h. Well, h and k, let's use this one. So there's our h, there's our k. So we're going to do minus k, which is +1. Our slope we said was -1/2. Quantity of x minus h, which is +2. And you'll notice, if you distribute that -1/2 and move over the 1, you would get this. Right? How you like them apples? So if you don't like plugging in the point to solve for b, do this one first, and then distribute. Right? -1/2 x, -1, -2. Okay. How you feel about that? Grand. How do we feel about finding the slope of between 2 points? You feel great. You feel so good. Rise over run right there, man. Didn't we go down 1 and to the right 3? Guess what our slope is? Negative 1/3. Or you could plug in the points and slope formula and figure it out. Yep. All right, let's find slope here. 5 going to 2. Down 3. 2 going to negative 5. Yeah. Down 2 to get to 0. Down 5 more to get to negative 5. Rad. 3/7 is your slope. Y equals 3/7. Wait, find the slope of the line given 2 points on the line, then graph the line. Is the slope vertical? Oh, okay. Well, we can graph that really easily. We don't need to write anything. What's the easiest way to graph that? Yeah, put your points down, draw a line. Haha. 1, 2, 3, 4, 5. Mr. Mac didn't make directions very specific. Easy points. 1, 2, 3, 4, 5. There it is. Is the slope positive, horizontal, negative, or vertical? It's positive. It's going up and to the right. Yes. Minus a million if you don't have the smiley face. I will throw away your exam. I'm going to turn right to page 21. No smiley face. In the garbage. You're going to super fail. So bad you don't get to take the test again. You just get expelled. Nope. Nope. 74. Let's just calculate the slope really quickly. Good guess. Good try. What does that mean? What does that mean? Bye. What? No, I have them all. Thank you. Undefined slope, which means what kind of a slope? Vertical, horizontal, positive, or negative? We're rising 7 and moving over 0, right? So when we graph this, check it out. It'll be 6, 4, 6, negative 3. Boom.
Well, that's a great straight line.
Solve the linear system by graphing. Mr. Mack, I'm sorry. I didn't get a page 5 on my exam. Oops. Solve each linear system by graphing. Eat it. Just eat it. Eat it. There's no evidence.
My dog ate my homework. My dog ate my homework.
Solve each linear system by graphing. First of all, what form are those equations in? Good. So they're super easy to graph. Graph them, see where they intersect. Good. 76. What form are those in? Standard. So how are they easy to graph? What makes it easy? Yep, plug in 0. Again, don't do it 1 for each, do it both for each, right? So 1 for 0. This is what I write before I do anything to make sure I don't goof it up. When I plug in 0 for x, that goes away, and I get 3y equals negative 12, which means it's negative 4. When I plug 0 in for y, I get x is negative 6. And now I don't goof those. A lot of people will switch these because they won't be thinking. Don't let that be you. How do you do it? That takes a lot of extra work. All you need to do is graph it. She's like, not going to change. Okay, fair enough. Plug in 0 for x. That's gone. What's 2y? What's y going to be? 9. Do you see it now? That's why it's easy in standard form. Because you plug in 0, it's gone. Because 0 times 2 goes away. All right, so we can plug in 0 to any equation and see what happens, right? What's nice about standard form is it's really easy to plug it in, because when you plug in 0 for x, it goes away, it disappears.
No.
We almost had her, and then we got interrupted. Oh no, it's okay. Happens all the time. We had her in the zone, she was so close to getting it, and then just lost focus. So, if we plug in 0 for x, look what happens. -3 times 0 goes away. That's the beauty of standard form. Whenever you plug in 0, it makes something go away, and now it's just 2y equals 18, which means y is going to be 9. If we plug in 0 for y, well, 2 times y goes away. What's x going to be?
Either 6 or -6.
-6.
-6, because 2 negatives make a positive, right? Remember, multiplying by a negative just means change the sign. So if you take -3 and multiply it by a negative, it's just going to change the sign to a positive, right? If you take 3 and multiply it by a negative, it's going to change it to a negative because it changes the sign of the original
I
number.
kind of forgot how to graph the points.
Okay.
X plus B form.
Oh, yikes. Okay, so 75. Y-intercept is the intercept, right? It's not. Don't call it y equals mx plus b form. Call it slope-intercept form, and you'll remember what it means. Intercept, y-intercept. Slope, right? Okay, so 3, the slope of 1 over 1, right? -7, 1, 2, 3, 4, 5, 6, 7. Slope of down 1 over 1. So down 1 to the right 1.
What?
Yep, I knew that was the issue. Nevaeh, is it true that 1 is the same thing as 1 over 1?
Yeah.
And that's the same thing as -1 over -1?
Yeah.
Good, so -1 is going to be -1 over 1, or it's 1 over -1.
I don't see it. Oh, it's -1x.
Okay, exactly. So that's a negative. And again, when we read that for the slope, a very common mistake is to think down 1 over 1. But that would be a double negative, right? Down and to the left. So it's either negative on top or negative on the bottom. So if you do down 1, it's to the right 1. Does that make sense? So down 1 to the right 1.
Okay.
And where they intersect is the answer, which is somewhere over here, probably. I don't know. Draw your lines well, because otherwise you won't know what the answer is. How do we feel about graphing this? 0, -4, 1, 2, 3, 4, and -6, 0. 1, 2, 3, 4, 5, 6. Those go together, and then these go together. Don't mix these up and think, oh, those go together. No, oh God. Nope. But you can tell really quickly that they intersect there, right? Because they share that point. What?
For when you're graphing systems with linear equations, then it's slope-intercept form.
What form is it in current? Oh, yeah, you don't know about the standard form thing. That's the thing you're struggling with. I'll give you a hint.
Why is it so blue?
Does that ring a bell? Good. Oops, he was in here when I was reviewing.
I think this should be right at this.
Remember when I put you guys in literally that spot, and then you moved?
No.
That's that right here.
Okay, nearly literally that spot. And then you're like, I don't like this seat. You move somewhere else, and now you sit way in the back. How's that working out for you?
You should move me away from Jaden. All he does is watches YouTube on his computer.
I know. It's not working out so well.
You should move me away from Jordan.
Yeah, you move me away from Shion.
That's probably a good idea. Yeah, you guys are not good together.
Me and Shion.
You work together. You do.
Me and Shion get distracted.
Yes,
by each
you
other.
do. Shion is a distraction. She is a mess. Her portfolio was beautiful. Shion, shout out to you if you're watching this at home. Your portfolio was amazing. Okay, best portfolio all day.
I get it.
Okay, it was like done on some like crappy paper and stuff, and like it wasn't like the most good looking or anything, but it had everything in it, and lots of it was good looking. Great job. You want to see 77 or 78?
No.
We would try to watch the
79, 80?
No.
Wait, what
Solved by substitution? That's Nevaeh's method.
I love
Nevaeh loves. Oh, all three of you do. What about combination? Yep. Okay. It's easy if you know what you're doing. So let's look at 81 as an example. We need to get our x's and y's lined up. We need to get it in standard form, really, is what we want, right? So I'm going to do this. And now it's in standard form, and our x's and y's are lined up, right? So now when I subtract y's will go away. So I'm going to subtract everything. Okay? So y minus y is 0. Again, check to make sure it does actually go away. If you said addition, it wouldn't have, right? 7x minus 2x is 5x. What's negative 5 minus 5? So many people say this is 0. Thank you. Negative 10.
I see 2 subtracting times and then you just add them. Oh, negative 2?
Yep.
Okay, can you explain that?
Yep. Y minus y, 0. 7x minus 2x. Negative 5 minus 5, negative 10.
So it's adding a negative.
Oh, God, that's convoluted.
You just
Huh?
take more off of negative.
It's negative 5 and you lost more. Yeah, exactly. Right?
I do it negative 5 and then you add the opposite.
Yeah, but that's I hit, like so many. Okay, that works for you, but I wanna rant about do the opposite. That's a terrible thing to memorize because so many things are do the opposite and so many things are not do the opposite, and then you're gonna forget which one it is, right?
I get this one. I've been doing it since last.
And if it works for you, great. Okay, but it's negative 5 minus 5 more, negative 10. Okay, so x is negative 2. Now we're gonna take that and plug that back in and find y. I'm gonna plug it in here. What's negative 7 times negative 2?
14.
Minus 5, 9. Good. Moving on. 82. Are x's and y's already lined up?
No.
Nope, they're close. We just need to rearrange them. Yep, I just flip them. I don't change the signs because I'm not flipping them across the y or the y-axis. I'm not flipping them over the equal sign, right? I'm not moving them to the other side. I'm just switching their arrangement so they stay the same signs. And now I'm here.
Multiply the top times 2.
And what do we get? 10, negative 6, and 60. Are those the exact same numbers? So that means the exact same equation, which means they have how many solutions?
No. Infinite.
Because of the same lines, right? They're always intersecting, infinite solutions. Because you're going to get 0 equals 0.
How do you draw that sign thingy with not turning it?
Watch.
I do 2
Here.
circles. Do 2 circles.
Mm-hmm.
I don't like it. You mold me.
Oh, homie.
What's up, Schlaffer?
I see infinite.
Schlaffer's always here.
I almost got arrested after school.
I heard about that BB gun incident.
You told him?
Oh, yeah, he told me. Parker and I are bros. Yeah, just chill, man. Be cool. Be cool.
Airsoft gun looks like an M16. Hunter gave me a ride home. And I went, Hunter, look at my gun. He's like, I know it's fake. I see the orange tip. So I said, oh, it's not live, isn't it?
Yeah, it is. Mm-hmm.
Well, anyways, long story short is, I showed Hunter the gun. It was fake. I had to flip out and everything. And a little girl across the street seen it, and she ran all the way down the street to her house.
Oh, I bet. Yeah.
And I was like sketched out. I wanted to say, I'm like, come here. It's nothing bad, but I was like, she's already traumatized. I'm not gonna call her over here. So now I'm gonna go find out where she lives and tell her parents, explain the story, tell her I'm sorry.
You lead a very interesting life.
Is that what you did?
So, yeah. She thought I was gonna.
Not so funny, but also
She
relevant.
thought I was gonna kill Hunter.
Yeah.
It's not funny.
Not quite as funny, but also relevant.
You can draw.
There have been people shot for carrying stuff like that.
Yeah, I know.
But usually they have different skin color than you, and so they're assumed to be like
Well,
bad.
And it was at my house, and it's in Morrison, Illinois.
Exactly, right.
So there's factors to
Yep,
it.
exactly.
Yeah,
But it's something to think
I live
about,
on-
right?
I live on like the bad part of town.
Mhm.
Morrison, Illinois.
Yeah.
So I live like on the main street of Chinatown, basically. Chinatown.
Gotcha.
I knew it was wrestling week 30 minutes.
83, you want to see it or no?
87.
No. Wrong.
Multiply top and bottom by 3 and 4.
Wait, what?
Then you get a big number of stuff that way.
Yeah, this is what I don't get. I spent 20 minutes.
And this
on
is
one-
why I phrased it that way after you said, nah, I don't need to see it. Right?
Yeah.
I know you guys better than you know yourselves. All right. We digging that so far?
See, I just did it coming in here because last time I was like, no. They shut the door.
Oh, yeah, you're both in. Oh, God. It's the dream team back there. All right. So, what ones do you want to make match? The Y's or the X's? Okay, you want to do that? Multiply the top by what? So everything times 5. I swear to God, you guys have a habit of just multiplying the first and then doing the other by random numbers. The entire top by 5. 29 times 5 is 100 plus 45, which is 145. 20 times 5, 100. 5 times 9, 45, right? They're running.
Basketball players?
I don't know. And then we don't have to touch the bottom, right? Because they already go away.
What?
Right? A lot of you tried to multiply the bottom by 3, didn't you?
Yeah.
But the question is,
did.
why?
I don't know.
I'll tell you why. What did I do wrong?
Stop.
What did I do wrong?
You?
Yep.
Oh, it's 15y.
Yep.
Plus 20x.
So we do this need this to be 15, and we do need to multiply this by 5.
I wasn't being dumb. I don't know what 3 times.
We have to times the bottom by 3, right? That's what we did. So that's gonna be a 9.
And it's for my brother.
This entire point was to make Nevaeh think, and Nevaeh is not even paying attention. Jordan's got it
I have
though.
my brother's name in my phone is dumbass, so I was wondering why he was texting me.
Are we subtracting or adding to get rid of the 15s? So we're subtracting everything. Gone. What's 29 minus 9?
11.
What's 145 minus 90?
Oh.
55. Oh, come on. It's 45 plus 10.
X equals 5.
X is 5. We plug it back in and find y. I'm not going to go any further.
Okay.
84 is any method of your choice. Distribute the negative 4. Do things, right? How do you feel about 85? This is our current test, I think. We finally made it. We're here. We did it, boys.
Oh, yeah, that's easy. That's X plus Y equals 2.
Yep.
X minus Y
Negative 7, right? The difference between two numbers is 6, or sum is 16, same thing. On the first day of ticket sales, the school sold 35 student tickets and 40 adult tickets for a total of $270. The school took in $366 the next day by selling 43 student tickets and 56 adult tickets. How much was the cost of each type of ticket? I know.
That's like the elimination thing, right?
Oh, elimination would probably be good. Let's try it. 35 student tickets, so 35 times the price of student tickets plus 40 times the price of adult tickets would get us a total of $270, right? You don't have to do elimination. You can solve it another way, but guess what? It's easier this way, which is why we teach you this method. Oh no, yeah, this one does suck. This one does suck, doesn't it? All 3 of these are divisible by 13, I bet.
Yeah, how do you know that? You just get
No, they're not. They're not.
I spent like 30 minutes on this problem just because.
You told us not to do it.
I know I did. What was I thinking? Well, the top's all divisible by 5. Let's do that.
But
Let's simplify it.
the bottom is divisible by 3. That's a big number.
It's okay, but it makes it better, right? Divide by 5 and we get 7. Divide by 5 we get 8. Divide by 5 we get 200 divided by 5. That's going to be 40. And 70 divided by 5 is what? Oh my god, I lost track. It's going to be 14. So 14 and 40 makes 54. That makes sense. 5 times 5 is 25. 5 times 4 is 20. 250 plus 20, 270. Then you said the bottom divides by 3, right? No, it doesn't. 56 does not divide by 3. Nope.
How does it not? Oh.
Because 5 and 6 makes 11. Also, 60 is divisible by 3, so 57 would be divisible, right? What is it? Yeah, if you want to, go ahead. Make it look nice. Some of the stuff's peeling off. Slopper, why are you here?
Because I'm waiting for the rest of me to start.
Oh, gotcha. Okay. I just want to make sure I wasn't ignoring you.
I'm gonna make them realize that they're missing out.
Which alma mater? Sandwich? Nice, rad. They have a really good wrestling program there for a long time.
No, I'm willing to dig up some dirt out of you.
On me? Oh, good luck. There are some pictures in the hallway. I was a model student.
Were you?
No. But I was in some of the good like reading groups and stuff like that. So there's that. I got an English award.
He read the AP version of Othello. It's an inside joke when we talk about
I still think it's funny.
Divisible by 12?
Nope.
Yes.
Not by 13. Not by 14.
He's just slapping him on the wall.
No, I put one.
Divisible by 17.
No, we did. No.
Well, 17 times 2 is 34. So 34 plus, nope. 18, 19. Did I just mess up a number? Is that what happened here? Okay, so let's pretend that it was 42 and 57. So now they're all divisible by 3. What's 42 divided by 6? 7, so double that would be 14. So it's 42 divided by 3, right? I don't know 42 divided by 3, but I know 42 divided by 6. It's 7. If we divide it by 3, I get twice as many, right?
Why'd you change the number?
Because it works out better. What's 42 divided by 6? Okay, so check it out. 42 divided by 6 is 7. So that means 42 divided by 3 is 14. We divide it by 2 over here, right? Do it to both sides. Because I know that answer off the top of my head. Why did I switch from 42 to 43? Because I don't want to divide everything by 6. I want to divide everything by 3. So that's going to be 19 because it's 1 short of 20. And that's going to be 122. Oh, and look at this. What happens?
It's half of the
Multiply everything by 2. This is probably what I meant it for it to be. I'm just an idiot.
you're not an idiot.
Sorry, guys. Oh, thanks, Nevaeh. Not an idiot. You are loved. All right. 0 equals negative 14. What does that mean? No solutions. So for this problem, the answer is no solutions, meaning there's no possible way they sold this stuff, which means somebody stole money out of the cash register.
It's 19.
By the way, I'm legitimately.
So they sold. Oh, A must be a fraction. Oh, it's $4 and
Yeah, dumb.
66 cents.
What?
That was the price.
We're done with that problem.
Okay,
Right? Okay, I made up numbers. Okay, it happens sometimes. Okay. All right, fair enough. We are upset. 88, the vote won. Again, the idea is to think about concepts. No, don't memorize stuff. Think about what it means.
U plus D.
What?
I'm like having a hard time setting this one up.
Yes.
So it needs to be
Don't do anything
3
dumb with
hours
it.
or more, but for this.
Did you empty that for me? Yeah. This man is a god. Worship him. Now, he did that not out of the kindness of his soul, because that is not enough, but also because if he doesn't do it, one of you morons will do it, and it'll spill everywhere. Are you kidding me? Which one of you morons? Which one? Which one?
I don't touch it. Like Grace or Laurel.
Corey, God bless you. Oh my God. It could have been my homeroom kids too. For real?
Well, do you have an RTI home, bro? Back this year?
This right here.
That has been a long time. Oh,
No.
No?
That's new.
Congrats, Dave. Hasn't that been there a long time? That's what I thought so too. Okay, either way.
It was like there maybe a day or two ago.
Oh, okay, so it might be new to Corey. I saw it a couple days ago, I thought, but.
So it needs to be 3 hours.
Thank you,
more,
Corey.
But like, the second one has to be 1 hour more than this one.
At least 1 hour more than that, yeah. So Olivia study time, let's use L instead of O. Olivia time has to be that, but more, right? It's not more than 3.
Jay's study time or Claire's study time has to be
More than this one, right?
more or equal to maybe.
Yeah, JS, right? Letters are hard. Plus 1, right?
Yeah, and then no less than, so like this and
It's gonna have to be less than in total. Yeah, you got this, you got this. All right, the boat problem.
Analogy of the day.
He's putting up there.
If you don't get paid, call the FDA.
Take that one down. I did not make that. Why are you shocked? No, it's not. It's funny only because it rhymes. And it's not even a good rhyme.
You need to cocoa time.
Are you still on your foot?
All right. Schlaffer, the humor is good enough for high schoolers, but it doesn't reach an audience outside of that. I highly encourage you to rewrite your material before you become one of those comedians that thinks they're funny, but they actually aren't. Oh, are you kidding me? Yes. I was awful. Remember, I didn't want to be a math teacher. A music teacher.
I wanted to be a swim coach so I could be on Lifetime TV.
I don't know how the two are related.
What?
I'm not sure how the two are related.
Oh my god. Well, I'll tell you when
All right, okay. Fair enough. We'll have an adult conversation, I guess. What is wrong with you, Schlaffer? Yes, it is, but it's there for a reason. It's fine. It's drying. Okay? That one's okay. That one gets the pass. That's an Euler curve, which you can only do if you take a spherical object and cut it. Okay, it's not drying very well, but it used to look like an Euler curve.
So, if all else fails, get an orange peel. If that doesn't work,
If you peel it the right way. Oh my God. Schlaffer, I'm going to kick you out of here.
You're lucky I'm not saying another word.
shut up, don't. You put another for a reason. I also wanted to know.
Yeah, I saw that. There's no stopping him. There's only delaying him. Ladies, Jordan, move your feet.
Oh, this is the one I did really good. Good job, Schlaffer. I'm proud of you.
All right, bad news, algebra kids. We have less than 30 minutes to get through the next 17 pages. Nope, 7 pages. Math is hard. 7 pages in 30 minutes.
7 pages. Can we just skip to the last one?
Do you want to see the boat speed one or no?
Yes.
Okay, well then we can't skip to the last one because that's the one we're on. So which is it? Do you want us to skip the last one or do you want us to do the one we're on? We can do 88.
Skip to the last.
Okay, so you don't want to see 88 or 89.
I'll figure it out.
Do you want to see 90?
Yes. Not what? Why do you want to see 90? Because it's the same thing as the equal sign in the... Yeah, the equal sign.
Jordan, it's okay. Hey. Top equation is this. We divide by 3. Do we have to flip the sign?
No.
Nope, so there we are. Let's graph that. That's in what form? What form is that in? Yep, so slope-intercept. So 1, 2, 3 is the intercept. Schlaffer, goodbye. I don't know what he said. Corey? Oh, I hope everything's okay. Corey has a key.
So you shut the door?
Corey has a key.
Why'd you shut the door?
On Schlaffer. Solid or dashed line?
Solid.
Solid. Now we're going to figure out which side we color. We're going to pick a point that's not on the line. I pick 0, 0 if it's available. Is 0 less than or equal to 3? Every time you say you want to skip it, you go, oh, wait, I don't actually get this one.
Where it's different colors and you have to find what are the possible.
Yep, I know what it is. Yep. So, we're going to choose a point that's not on the line, like 0, 0, because it's easy to plug in. When I plug it in, does it make a true statement or a false statement?
I don't know.
0 less than or equal to 3?
No. Yes. Yes.
They always say the wrong thing. Is 0 less than 3? Yes, it is. So 0 is less than 3, which is a true statement, which means we shade this side of the blue line. Yeah, anything over here would be a solution for the blue.
This is what I'm gonna fail right here.
No, you're not.
Yes, I will. I literally just physically do not understand it. Like, I tried using the colors that you use and it just doesn't work. Like, I just do not understand.
But you get why I'm coloring where I am and everything?
No. I get why.
Okay. So, think about it. Where we put the line normally is where we have solutions to our equation, right? That's what that is. That's what that represents.
Yeah.
So, this isn't just the line, but it's also anything less than the line underneath it.
That's the bottom part.
Now, will that always be easy to tell? No. So what I do is I check a point on either side of the line to see which one's true. If I checked over here, it would get a false statement, which means that isn't where the answer is, so I don't color there. Remember when we did this, right? Where was X? Well, if it was on this side, we colored that side, right? So we're doing it in 2 dimensions now. That's it, with 2 axes. Where is the right answer? Well, it's anywhere over here, including the line. Including because it's less than or equal to.
Then if there's just a greater or less than sign, like not the line.
It won't be the line, it'll be a dashed line, right? Because it doesn't include the line. Remember, where we color is where the answer is. This one, anything here and including the line works for this.
Wait, how do you know the answer's on that side?
Because if we were to check this side, like, let's check this point. 1, 2, 3, 4. So 0, 4 is what that is. 4 for y, 0 for x. Is 4 less than or equal to 3?
Oh.
No, so it doesn't work.
Okay.
But any point you would try over here would.
Do you have to use both of the equations? Or do you just have
What? Yes. So normally we have equal signs and we find out where they intersect, right? So remember when we have equal signs, they're just lines. And we find out where they intersect. The red line represents all the points where if you were to plug it into its equation would be a true statement, right? Anything on the blue line would be a true statement for it. The question is, where do they both agree, right? Well, this one, it's a bunch of area, right? So red's going to have a section that's just it. Blue's going to have a section that's just it. But they're going to have an area where they agree. They're going to have an overlap. It's just going to be bigger than a single point because they're inequalities. Okay? So, again, when we graph a line, what does that line represent? That line represents all the collection of points that would make that equation true if you were to plug them in. Where is this thing? Did I rip it? It might have been the one I ripped out. It might, oh my god, it might have been. Oh man, it probably was. Dang it. Okay. So imagine we do a graph and we find out where they agree, right? Again, the red represents all the points, right? That if you were to plug them into your equation, the red equation, it would work. The blue, all the points where it would work for the blue equation. Where they intersect is where they both share the same answer. So pretend it's like 3, 2. That means if you were to plug in 3 for x to either equation, you would get 2 for y for either equation. It's where they both had the same solution, right? Does that make sense?
Kind of.
Let's do an example. Two different lines, right? Where they intersect, okay, line 1, line 2, will be where they both agree. So I could plug in 3 here and get 6 plus 1, which is, what? 7. So 3, 7 is what happens when I plug in 3 here. When I plug in 3 here, I get 9 plus 1, which is 10. So they don't agree at 3, right? 3 and 7, 3 and 10. So maybe 3, 7 is here, maybe 3, 10 is somewhere else. Okay, I'll let them in. Terrible timing. Come on in. All right, so, yep, they disagree here, right? 310 shows up on this guy, 37 shows up on this guy, right? But they don't agree there. But watch what happens when I plug in 0. For this guy, 0, 1 pops out. What happens when I plug in 0 here? Also 1. So they both agree at 0, 1. Because they both have the same solution. 0 gets you 1 here, and it gets you 1 there. So that's where they agree. Does that make sense? Okay. Lots of points where they don't agree, but still are valid on their own, right? But one point where they both agree. This is saying I've got not only this intersection point where they both agree, but also this area where they all agree. Anything in there would work for both. So if I were to plug in a point in here to those equations, then it would come out true for both. If I were to plug in a point here to both equations, it would only come out true for red. If I were to plug in a point here to both equations, it would only come out true for blue. But if I plugged it in here, it would be for both. What would happen if I plugged in a point here to both equations? Here. It wouldn't work for either, would it? Right? So blue is saying any point in here, including on the line, would come out true. We know that because we tried points over here and they didn't work, right? Now we're going to find out where red has all its solutions. So here's the red equation. What's the easiest way to graph that? Jordan hates this method. What form is that in? Standard. What's the easiest way to graph standard form? Find your intercepts, right? Plug in zeros. Okay. So if I plug in 0 for x, what do I get for y? 7. Right? Or negative 7. So I get 0, negative 7. So 0, negative 7 is here. 1, 2, 3, 4, 5, 6, 7. And then if I plug in 0 for y, what do I get for x? Also negative 7, right? So negative 7 for this. 1, 2, 3, 4, 5, 6, 7. X and y intercepts. So there's our line. Is it dashed or solid? Dashed. Okay, good. Now, which side am I going to color? Because, again, it's not including this line, but there are solutions somewhere, right? So I'm going to test 0, 0 to see if it's this side that I color, because 0 is on this side of the line, right? When I plug in 0, 0, I get 0 plus 0, so that's 0. Is 0 greater than negative 14? Is 0 greater than negative 14? It is. So this side must contain all the sides that are true for red. So everything on this side of the red line. Everything on this side of the red line. So,
Makes more sense.
you see what I'm saying? Right? If you know what it means, it makes sense. Red solutions work here, and they work here. Blue works here and here, but they work together here, right? No solutions there. So again, I take purple, and I say this is where they both agree. Right? Feeling much better? Rad. How do you feel about this stuff? Good? Okay. I'm glad we caught that. Because again, it's so freaking easy and makes so much sense once you get it. But if you don't get it, it's like, what is going on? Right? And it's because most people don't tell you what lines are and what they stand for, right? It's all the points that work for that equation. This is all the points that work for both. Right? Jordan, are you with me? Kind of knew it. All right, let's try another one. 91. First of all, they're both in standard form. Jordan, me and you on this one. What's the easiest way to graph something in standard form?
Can't see anything, but
Do you know what I mean by standard form? It's when x and y are on the same side. Right? So like, ignore this if it was an equal sign. I don't think you'd be confused, right? Negative 3y minus 2x equals 12. That's standard form, right? Remember that? Okay. So if I plug in 0 for x, what do I get for y? Negative 4, right? So 0 comma negative 4 is what I get. So here's 0, negative 4. 1, 2, 3, 4. Now if I plug in 0 for y, what do I get for x? 6. Try again. Negative 6. So -6 for x, 0 for y. So that's this point. 1, 2, 3, 4, 5, 6. And now I draw my line. Is it dashed? It's dashed, right? So that means it doesn't include this line. This is 91. It's 0, -6, and I'm sorry, -6, 0, and 0, -4. Jordan, you want me to wait for you? I can. I'm not upset. I just want to know if you need some time. Okay. And if you don't need time, that's okay too. This one. Again, it's in standard form, so the easiest thing to do is plug in zeros. If I plug in 0 for y, what do I get for x? -6. So -6 comma 0, right? So -6 comma 0 is here. The same one. And if I plug in 0 here, what do I get for y? 9, right? So 0, 9 is what I get there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that a solid or dashed line? Do you know why it's solid, Jordan? Less than or equal to. Oh, I got it. It includes that, right? That's what that means. Less than or equal to. This one's just greater than, so this is like a boundary. It's, okay? So let's figure out which side we're going to color for the blue line. Is it going to be this side or this side? Remember, it's where the answer is true. So I'm going to try 0, 0 and see if that's something that works for the blue. So 0 in there and 0 in there gets me 0, right? Is 0 greater than 12? No, it is not. So that is not part of the solution, so we're not going to color this side. We're going to color the other side of the blue line. It's everything in this blue area up to that line, right? It's like a boundary. You can go no further, right? The solution stopped there. And it does not include the line. For the red, let's try 0, 0. Will we color this side of the red or this side, right? I'm going to test this side. 0, 0 gets us 0. 0 less than 36. Is that true? Yes, so we're going to color this side of the red because that's what side 0, 0 is on, okay? So here we are. This side of the red line. And now you can see where they agree. And that's the solution that works for both. Down here. Anything under the blue line but not including it, and anything under the red line and including it. Actually, would it include it? It would include it. Yeah.
This is so pretty.
It can be if you do it right. Aww.
I just pick. I don't have
So let's take a break and talk about what lines mean again. Remember, lines are a collection of points, right? That when you plug them into the equation are true. Right? Anything off the line, not going to work. Okay? When I have two lines and they intersect, we're saying that, look, they each have their own solutions, but they have one spot where they share the exact same thing. Like when you plug in 2, you get 3 for both, something like that. Okay? When we do this stuff, we're saying maybe red not only includes this line, but it's anything greater than that. So that would be up here. Anything above it as well, right? The blue line says anything below it. I know I'm mixing up my colors here. Sorry. The blue line, the bottom one I'm saying, okay, is anything below it. So that's going to be below the blue line. That's this side. Now, where do they both share solutions? It's here. Instead of just sharing in one point like lines do, inequalities share an area of points that work for both, okay? Because there's a lot more possibilities, right? You could have a number smaller than 3. Well, there's lots of numbers smaller than 3, right? Not just specific ones. Something that equals 3? Oh, well, specific, right? Now, when we have a dashed line, Jordan, that means it doesn't include the line, meaning that anything on this line wouldn't be part of the solution. It'd be everything up to that line, but not including it, right? So that point wouldn't work, but the point right next to it would. The red line is solid, meaning that anything here works, but so does something right on the line. Does that make sense? Okay, we'll take better. How do we feel about 92? Almost out of here, guys. Jordan, would you say that pretty much everything up till now you don't really need to study except that last little bit? Okay. Then that's not a lot to study for a final. You'll be okay. Yeah, just to make sure you've got it, but it won't be something you're trying to teach yourself.
The middle stuff I get.
Mhm. The beginning when you tried to BS it early on. Yep.
Can we do numbers 96 and number 9?
Do we need to see number 92 or no? I'm losing Jordan. Jordan. We need to see 93. He's got keys. All right. I figured you had keys and Schlaffer didn't.
Yep.
All right. As far as I'm aware, he doesn't have keys. I had keys to everything in college. 93. We need to see it or no?
It says Jordan's name.
It does say Jordan's name. Okay. Jordan needs to spend at least 2 hours doing homework. So the amount of homework time, I'm going to call that H, right? I'm going to show all my work so you can see where my logic is, okay? Homework time is H. But she also wants to hang out with Olivia, so we're talking Olivia time. I'm going to use L for Olivia time. She needs to spend half an hour more hanging out with Olivia than studying. Okay? So the amount of time she spends with Olivia has to be a half hour more than she does homework time, right? So this needs to be a half hour more. So it needs to be exactly a half hour more than she spends studying. Does that make sense? The amount she spends with Olivia is going to be whatever she does studying plus a half hour more, right? Are you smelling what I'm stepping in there? That's the hardest part to come up with. You see my logic here. We also know from earlier, 2 hours doing homework at least. So H has to be at least 2 hours. Equal to is fine. Greater than is great, right? Then it says studying and hanging out with Olivia must total under 8 hours. So when we combine H and L, what do we know about it? Yeah, so how do I write that mathematically? Or equal to 8. So there we go. This is the stuff that matters. That's what it means. This is the hard part to set up, right? The amount of time she spends with Olivia is whatever she does for homework plus a half, right? So now let's graph this thing. Well, we need H and L axes because we're not using X and Y. So I'm going to zoom out and label my axes H and L. We'll do H on the right for the X-axis, and we'll do L for the Y-axis. So first off, H is greater than or equal to 2. So here's 2 on the H-axis, right? We want all the points where H is 2. So 2, 0, 2, 1, 2, 2. Does everybody see how that's a vertical line? Are we cool with that? And it's greater than or equal to, so it includes the line, so we color it in, right? Line underneath. Right? Solid line. Greater than 2. Now, again, if you're clever, you'll know greater than's to the right. But if you needed to, check 0. See if that's where we color, right? If I plug in 0, is that a true statement? It's not. 0 is not greater than 2. So this is going to be the side where all the solutions are for the red, right? This pen is dying just in time for Christmas. All right. Then we have 2 other equations we're going to graph. So what form is this in? Standard, right? So let's plug in 0. If we plug in 0 for H, what do we get for L? We get 8. So L is 8. 1, 2, 3, 4, 5, 6, 7, 8. And it's solid line, so we're going to color that dot in. If I plug in 0 for L, what do I get for H? 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Solid line. Do we have to do any coloring for this one? Yes or no? Do we have to do any coloring for this? Why do you say no? Not sure?
Nope.
Is anybody sure and can explain why we color or don't?
Doesn't that line not really matter?
Part of it doesn't, right? Because you already know that bit's not going to be part of the solution, right? Good thinking. We do have to color because it's an inequality, right? Regular equations we don't, right? 'Cause it's just a line. Equations are just lines. But this is going to take some coloring. So let's test a point, 0, 0. If I plug in 0 and 0, I get 0. Is 0 less than or equal to 8? Yes, so anything on this side of the purple line will be a solution. Now you can probably already see where they're sharing, right? And where they're not. So if you want to color without using colors, right, using pencil, what I would suggest, Nevaeh, for instance, and Jordan, you know this isn't shared area, right, over here. Over here is not shared, right? So why even bother coloring it? You know here is shared, right? So color in that even darker. You see what I'm saying? That way it's easier to tell what they share and what they don't. Okay. Lastly, we're going to graph this guy. I'm going to have that be a blue equation, okay? That way you can see what's going on. Do I need to color for this one before I start? No, because it's an equal sign, right? It's an equation. It's just going to be a line. What's our y-intercept here, otherwise known as our L-intercept? A half, right? Is our y-intercept, L-intercept. That's y equals mx plus b form, right? What's our slope? Up 1 over 1. So watch this. Up 1, still a half, over 1, in the middle. Up 1 over 1. Do you see how it's still in the middle since it started in the middle? Because I'm going up 1 over 1. Now we're not going to color for this one because all of the solutions are only on this line. That's what an equation means. The solutions are all on the line, none to the left, none to the right, just exactly on the line. It's an equal sign. It's all about exact, right? So where do they share? This area right here. I'm going to highlight it in green. We have red coloring, green coloring, and our blue line all in here. I'm circling the line. So that's where they agree. Very limited amount, right? This thing really limited stuff. And that makes sense because if L has to be exactly half more than H, that's very limiting, right? There's not a lot of options there. So that's the solutions that you could have. Anything in there would work. So Jordan can get to bed on time, and she can hang out with Olivia and not be called a nerd, right? Can't do too much studying. Thank you, Corey.
It's his fault.
That's right. We are pro-bullying in the Mr. Mac room. That's right. Bullies need friends too. This is Jordan's mood. X-axis is time. Y-axis is happiness. This is the Mountain Dew. She didn't have any. Now she did.
That was beautiful.
Right? Someone get her caffeine now. Don't tell mom and dad. Need some apple juice. Apple juice and graham crackers. Are you sure it was apple juice? That's right. Never drink strange apple juice. 95, 96. Want to see him? 96. All right. Brace yourselves. Oh, no. Yep. She is technically early, but... All right. You guys ready?
Yes.
Here you go. This one's going to take a while. What's up, Parker?
Didn't I do this right?
That's close, and the shared area is there. I'm not going to check your work, but the idea makes sense. Okay? All right, you ready? Farmer has 30 total feet of fencing for use for an enclosure next to a river. So we know that the pen doesn't need a side here, right? So it's just X and Y. I'll do it in red. We cool with that? She wants to maximize the total area of the enclosure. What's the area of an enclosure like this? Well, it's a triangle, right? And the area of a triangle is going to equal what? Exactly. Base times height. Oh no, that's red. That's red. That's red. That's red. Half the base times the height. You might think, what about base? What are you talking about? Well, if I turn it this way, doesn't that become like the base of a right triangle, right? It's all about perspective. Don't be freaked out by the angle, right? So base times height divided by 2, or halved, right? These are our restrictions. We also know what about x and y? Not equal, necessarily. They could be different values, but they have to be greater than 0. They can't be 0. They have to be greater than 0. All right. So all that means is that our solution area is going to take place in one quadrant. The quadrant where x and y are always greater than 0, the right quadrant. So now I'm going to draw my graph, okay? You guys ready for this? We learned yesterday that this is how long across? 30, right? So I'm going to draw my graph, 30 up and 30 down. Why? Oh, yeah, that's the other thing. Sorry. One last restriction. What else do we know about x and y? They have to add up to 30 for this problem. Right? In total, they have to add up to 30 because it's going to use the whole fencing, right? We good with that? I don't want to lose you. This one's the tough one, and then you'll feel really great if you get it. It's hard to get if you're not paying attention, though. Are we good with this and where it came from? Mm-hmm. Yeah? Okay. So I'm going to make a graph. I need to graph this line, and I know my x and y intercepts will be 30, right? Because if I plug in 0, I get 30 for y. 0, I get 30 for x. So I'm going to need a graph that at least goes up to 30 in both sides. So here I go. Ready? 30 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Bye. That's 30, I'm pretty sure. 30 this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30! You missed it. You missed it. Go back and watch on the live stream. Yep, it's happening. All right, so 30 by 30. Let's label this by 5s. It's the worst. Let's mark this off by 5s. 5.
My mom was here. Well, my mom doesn't stop in the back. She just the type of stop sign.
Bye, Nevaeh. You can always watch the end of this stream or the end of the other stream I did the other night. I definitely would. Hopefully it makes sense. Other night's explanation was great. I'm not sure how this one's going to go, right? This is a hard concept to do. Other night, it clicked. So watch that one. 1, 2, 3, 4, 5, if you don't get this one.
Thank you.
Yep, of course. Where's Troy? Okay, that's fair. That's fair. No shame in that. I just wanted to make sure I didn't need to wait for him. All right, so there's our graph. Now let's graph this stuff. We know x and y have to be greater than 0. That means it's just in the first quadrant, right? So I already took care of that. Do we get that? I didn't draw a full coordinate plane. I just drew the first quadrant because x and y have to be greater than 0. I also know that x plus y equals 30, so I'm going to graph that. Our intercepts were 30 and 30, right? Are we cool with the intercepts being 30 and 30? Okay, awesome. So I'm going to draw my line. Here we go. Here it is. Okay. And let's use blue. I don't remember. Let's use purple. Let's use purple. think I did red last time. So purple should be okay. All right. So what does a line represent? All the possible solutions that would work, right? And normally it would go on forever, but we cut it off here and here because x and y have to be greater than 0, right? So now we're going to test a bunch of these to figure out which one gives us the best solution to maximize the area. So let's test 5 and 25. That's right here. Okay? That's 5 comma 25. Now, if x and y are 5 and 25, if we plug that into area, what's the area going to be? Well, 5 times 25 is 125. So our area for the triangle would be 125 over 2. We're just going to leave it all over 2 because everything's going to get divided by 2. So why simplify? What? That's okay. All right. So that's one option. We want to try and find a better option over here. Okay? Let's try 10, or let's do better. Let's do 15 and 15. Area for the triangle would be 15 squared. 15 times 15, that's 150 plus 75, so it's 225. Of course, divided by 2. That's okay. 15 times 10, 150. 15 times 5. It's 50 plus 25, which is 75. Okay? Yep. Yeah, that's fine. That's fine. So, yes, you can. Oh my God, of course. Yes. What? Come on. I'm not the SAT. I'm not park testing. Why would I ever do that? I know what I can answer and what I can't because I made the exam, right? So, anyway, is this number bigger or this number bigger? This one. So if we find a bigger number in between here, right, then that means the small numbers must be over this way type of deal, right? So I'm going to check this number here, 10 and 20. What's 10 times 20? Divided by 2, right? I'm just going to write it like this, 200 over 2, because it's easy to tell which one's bigger. Why are we multiplying them? Because we're maximizing the area. Right, these are the possible numbers we can check, right? So the area's here. Which one's bigger? This one, right? So worse answers must be over here, and I don't want those. Do you see what I'm saying? We want to cut this line down to half the size it was before. The size it was before was root 1800 because 30 squared plus 30 squared, I'm doing it Pythagorean theorem, 30 by 30. 30 squared and 30 squared makes 900 and 900, 900, 900 makes 1800, 1800 rooted. You with me? Okay, yeah, right? Exactly, right? So we want to cut it down to whatever half of the root of 1800 is. I will give you better numbers than that. Half of root 1800 is around 35. Okay, so we want to make sure that's shorter than 35. Okay, so I'm going to try another number. Let's try 20 and 5 down here. Oh God, or 20 and 10, I should say. That's here. Now, notice that 20 and 10 for this type of problem should be the same as 10 times 20, right? So it's also going to be 200 over 2. Which one's bigger, this one or this one? This one. So we know worse solutions are there, right? The bigger one should be in here somewhere. Now we got to find closer and closer and closer. Turns out this will be the best because it's a really simple problem. Halfway for both is the best, right? Closer and closer and closer. Now, if I wanted to stop here, the question is, have I limited the possible solutions to less than half of what they were before? Well, how big is this section? Right triangle. Well, it's between 10 and 20, which is 10. And it's between 10 and 20 over here, which is 10. What's 10 squared and 10 squared? 100 and 100 added together, root 200. So this is the root of 200 from here to here. We wanted less than 40. I'm sorry, less than 35. Is the root of 200 less than 35? That's what we need to ask. How do we estimate that? We know that 10 squared gets us 100. And if we doubled that, we get 200. So it's somewhere between 10 and 20 as an estimation. And either way, if it's between 10 and 20, is it less than 35? Yes, so we've cut this by we've cut it down to less than half, which means we're done. So how do we write our answer? We know that x and y, x is between, looks like 10 and 20, right? So it's between 10 and 20. Our best answer for x is between 10 and 20. This is a super simple problem, so it's the same for both, right? And I know that y is also going to be between 10 and 20. That's my solution set. It's somewhere in between there.
Now that like we can actually like focus, I can
Focus is super important.
I'm not
Okay?
focusing.
Best of luck. Watch the review. Try the other one. It'll be simpler because area won't be half xy. It'll be regular xy because it's a rectangle. Actually, it won't be xy. It'll be x squared y for the. It'll be 2xy. 2x plus y for the. Oh god, I can't think. Just leave. Just leave. Just leave. Just leave. Bye. Want to maximize the area? It's xy. xy is the area of a rectangle, even if it's missing a side. It's still the area. All right, I'm gonna take a break for a second, and then Mitchell will answer your questions, and we'll get you out of here. See if we have anybody watching at home. Hopefully we do. I know, like CJ and a couple people.
Yeah.
They were saying that they wanted to be here but weren't. I really hope the screen's still running. It says it's like lagging, but hopefully it's just this. Usually it is just that. Okay. I think it's just the window here. Like the preview. Because I'm not disconnected from the internet, am I? Oh my god, would that be bad? Okay, we're still connected. Good. It wouldn't be the worst thing in the world. I just upload the video because that's why I always record to my computer and directly to the internet, which takes up a ton of room in my hard drive. But so far, I've had no issues. I've recorded a video pretty much every day for every class for like 3 months now, and apparently my hard drive is like, nope, we're still good. What a boss. Terabyte, man. It's a freaking load of room. Terabyte is an extraordinarily large amount of space. Although for music production and stuff like I used to do, which I don't really do much anymore, that fills up really fast. Right now I'm working on 2 camera angles, not like 20 million like real producers do for video. And that's like 20 times the amount of video, right? Whew. Okay, so which ones you got questions on? Then we'll get you out. 45. Let's see if we did it. We didn't? Oh. Yep, okay. So we didn't do it. Ignore that. That has nothing to do with it. 45 is this. So we take them separately, right? I'm just going to do 6x greater than 12. X is greater than 2. I don't need to flip the sign because I didn't divide or multiply by a negative. And on this side, I add 10 and get negative 90. And I divide by a negative, so I flip it and get 10. So the way I would write this is either just like this, or because it's an and statement, it's saying x is between 2 and 10. There's 2. There's 10. It's between it. X less than 10. Check. X greater than 2. X greater than 2. Right? It's and, so it's between those two numbers. So I would write it like this. X can be any number as long as it is between 2 and 10. And when I graph it, 2 on the left, 10 on the right. Open circle for both. It's between, so it's here. Feeling better?
Yeah, I got 52 and 53.
Okay, real quick, 47. Would that be an and or an or statement, you think?
A 10, an and.
Yeah, because look, it's going to be something in between two numbers, right? Nice, good thought. I love how you guys can think about math and actually know what it means. 53?
52 and 53.
Oh boy, okay. So we already did these. The member cost would be $200 plus $6 times the courts, right? Number times they rent. Non-member is 15 times the courts, okay? So the question is, when is member cost going to be less than or equal to non-member? When is this a better deal is what we're asking, right? So what is member cost? Well, it's this. What is non-member cost? Well, it's that. So when is this less than or equal to that? We do math. We find it's 200 over 9, right? Now, we can't rent the court 200 over 9 because that's going to be a fraction, right? But that's okay. We can still write it like this, but we know that C has to be a whole number, right? It could be 0, it could be 1, it could be 2. It just can't be a fraction. It can't be negative, right? So even though it's saying anything greater than 209, this restriction here kind of takes care of that for us because, yeah, it has to be greater than that, but, oh, yeah, it has to be a whole number, right? Okay? So gets you either way. 53, ignore this. The setup amount left over is going to be $600 minus $35 every week, and it has to be greater than or equal to 250, right? We want the amount left over to be equal to or greater than 250, right? So amount left over has to be equal to or greater than that. Do math. We have a double negative here. When we divide by negative 35, it flips the sign, and we get W less than or equal to 10. That means W is less than or equal to 10, and W has to be a whole number. Because it could be 0 weeks, it could be 1 week, it could be 2 weeks, it just can't be half weeks, right? So there's the set. Feeling better?
Yeah.
Rad. 55, you said?
Yes.
Okay, we did not do that one. So here's 55. If you have a starting salary, okay, so we have two different jobs. Here's what's going on, right? So job 1, right, is going to be $34,000 starting. So that's $34,000. And then a yearly raise of $1,000. So it's $1,000 added on to that every year.
I just saw somebody come in, I couldn't see the face.
Job 2 is offering $25,000 starting and a yearly raise of $2,000. So you start out with more here and gain less over time. Here you start with less but gain more over time. So the question is, how many years will it take for each job's total salary to be equal? And what will the salary be at those times? So we want to know when this is equal, right? That's what we want to know. So this isn't too bad. I'm going to subtract 25,000 to this side, and I get 9,000. I'm going to subtract 1,000y from this side and get 1,000. Right? Divide by 1,000, I get 9. 9 years is when they're equal. Now, what will the salary be? Well, if I plug that in, I'll figure out what the salary total will be, right? Well, after 9 years, I'll be making $34,000 plus $9,000 at job 1, which means I'll be making $43,000 a year, right? What will I be making over here?
18,000 plus 25,000 would be 43.
Yeah, it'll be the same, right? Because that's what we were solving for. Didn't even have to do the math. You know it's going to be the same if you did your math right earlier, right? So it'll be $43,000 at both jobs. If I wrote, like, when this one would be greater than, that would be another question. Like, when will I be making more? Because, right, I got to catch up. You could do the same thing, right?
64.
Finding slope. Good with that?
Yeah.
Plug it into slope-intercept. Find B. I just plugged in one of my points, right? Because if that's on my line, then it should be a valid solution. B has to be -2. So there we go. Or you could have started here and did point slope form, right? I chose to plug this in. Minus K is +1. Minus H is +2. You smell what I'm stepping in? Right? And then you could distribute and you get this that way. So if you want to solve for B by plugging in the point, or if you want to just like distribute and do math to get that, that's fine too. What else do you need to see?
84.
84. Okay. Using any method. So which method would you use? Yeah, probably, right? Let's get y on its own in the top, right? So I'm going to write this one as y equals negative 4x plus 8, and then we subtract 2, so it's plus 6. You dig? Distribute, subtract. Rad. Okay. And then this one we're going to keep the same. Oh, we're going to take that and plug it in, right? In here. So we're going to do a half times whatever y is. Always wrap it in parentheses when you're plugging in a quantity, right? Plus, why am I writing that in a different color? 2x equals 3. So we're going to plug in negative 4x plus 6. This is why it's so important to wrap it in parentheses, because that minus sign, right? And we do need to distribute the half. When we distribute the half, that's going to be negative 2x plus 3, right? Feeling good? Notice the negative 2x and positive 2x cancel, and we get 3 equals 3, which means these equations must be the same. Infinite solutions. Rad. You can destroy this exam. Destroy it. Okay, you're going to get to this last problem, like this one, and you're just going to wreck this thing.
That's like before when you're doing up-down, it was so hard for me to follow.
I know, but now it's like, I am a god, right? And that's like intro to calculus stuff right there. So that's, you know, kind of exciting for a math teacher to be like, yeah, my algebra students that are freshmen can do intro to calculus stuff. They're kind of freaking amazing. So, oh, you know, we've already done calculus. I figure we go on to differential equations, you know, topology.
No, I gotta go home and study biology for the next.
Nice. Yeah, don't worry about math. You're good on math. Okay, you'll have time to study for it during the day probably tomorrow, right? Yeah, go knock biology
First
out.
hours, so kind of not. But
No, I meant math you'll have time to study for.
yeah.
So worry about biology. Math, study a little bit during the day. It'll be fine.
Tomorrow
I'm going home.
It's gonna be so easy for me. Well, not tomorrow. Well, tomorrow, yes, but Thursday is gonna be the easiest thing ever.
Yeah?
Because I have Spanish, which as long as I halfway study, I'll be okay. Computer apps, which we're literally just watching a movie, and health, which is only going to be over the past 2 weeks.
Sick. Do you have every class with Nevaeh?
I have a lot of them with
Okay, I was going to say, her schedule sounds really similar. You're going to be okay.
Yeah.
You really will, okay? See you later, Mitch.
Thanks, Mr. Mac.